Taildrich. Alright. Yay, Scorpra. Oh my, indeed. Alright, I guess let's see if we can find... question off the internet. When's the beard rematch? I don't know. Bob said that he's down. I want to... I have a couple ideas for things that we can do, but... what the hell is happening here? Is this high school integration? I need to actually like kind of write things down though. I was thinking of just finding like those sweet games I could on Tabletop Simulator, and I have a good few, but I need to see if they're like 2-player or not. That is on sale. Ooh, awesome, Jed. Yeah, if you do get it, please let me know and I'll add you to our group chat. Today, which changed subs Monday? 9. I have no idea what that currency is, I'm gonna be honest. Either way, that's still like what, nearly a 5 times increase? That's crazy. Like they're oh, the lira, okay. Really? So Twitch updated their local pricing for subs? When was this? I don't see a date on this, at least. I have to look up. Ah, it's okay. Well, I'm sorry that they're so much more expensive for you know, Eldritch. It's not something that's really. It's not something I can do anything about, though. Unfortunately, today or tomorrow. Oh, okay. This kind of lacks some context. High school integration. Is this force? Like linear force or something? Just completely guessing. We have a rho, a phi, an r, and an omega. If we have a sine and an omega, I bet it's something like a spring or something physicsy like that, or a pendulum. This needs a lot more context though. This doesn't seem like a high school problem at all. Hey, Yanis. You only know what the 1/2 means, or just Minecraft enchantment language? It's a hilarious way of describing like all the Greek letters that go on with math. The Minecraft enchantment language. Yeah. $0.25 for a sub? Oh my gosh. Should move to Turkey and buy subs for everyone. Be a king. Jeez. Whoa. You know it's serious when they're using capital gamma as a set? You're moving to Turkey? Why is your streak still there? Apparently they can sometimes take a minute to update. I just feel like that's what Jed has said before. No, I didn't stream yesterday. I don't usually stream on Mondays. I sometimes do, but I'm not like scheduled to. How's it going, Scorpio? Are you still playing Helldivers? I don't know what that problem is. Gonna spread some democracy soon. Nice. For some weird reason, your phone likes to capitalize words. Should be one of those people who, like, when they type, they capitalize every single word. I feel like it's not as common anymore, but, like, it always cracks me up when people do that. It just looks so weird. Oh, you're getting fiber internet next week? That's super hype. Dude, I have fiber internet here and it's so nice. I don't want to live anywhere else just because of that. Super fast internet for cheap. Just as long as it doesn't do this. Now that's really annoying. Like that I just hate to like read. Well, I mean like the first letter of each word. Way cheaper than your current? Oh, that's awesome. Dude, can we have some normal questions? Oh no. I see that. I would say that's I see the for all symbol in there, but of course it's just upside down capital A. If you can read this, you must live in Australia. I'm reading one of those Facebook things where they would like the first and the last letter in the right spots with the middle of each word are like all scrambled around. And they'll be like, did you know that you can actually read this quite well? More than 12 Mbps upload speed? Awesome. Being in a place with bad internet really sucks. Okay. That's some kind of calculus problem, I guess. Consider 50 mile by 50 mile. Oh no. Yeah, like well, it wasn't those exact words, but that was definitely a trend on Facebook for a hot second. Also, please let me know if the music becomes choppy at any point. I've hopefully fixed it using a really stupid workaround solution. It's only been the stream's only been going for like 10 minutes though, so it might not happen for another like 20 minutes potentially, but I'm hoping it just never happens. Let's determine how many fire breaks to place. Fire break is equally spaced as a cut fully from one side of the region to the other in a straight line a half mile wide. The region between the breaks that is on fire is totally consumed but can now spread outside that region. Okay. The number of breaks you should place to maximize or to minimize the total area lost from the fire, as well as the amount of area lost. So the minimum breaks to minimize the damage to the fire. Those are two conflicting goals, though. Huh. Is this really a calculus problem? Well, Eldritch, that's where you're not in luck. It actually says there's no problem I can't not solve, okay? Which means if you give me a problem, I promise you I can walk away from it. Just like I can walk away from trying to fix your government and economy. I need to get rid of this ping on Discord. I don't know why you need to ping everyone just to say that. Okay, anyway. So, I don't know if we need to bring probability into it. I feel like you would, if you were actually doing this in real life, you would just make a few examples with like from 1 break up to like 10 breaks or something, and I don't imagine you would do more than 10. Because each is a half-mile wide, so you're losing 5 miles of area there. Identifier is the lost value of the burned land. I guess how do you assign value, though? I assume this is like wild land, not like real estate. A is overall area. B is area the breaks take up. Okay, so like the total area of the breaks. N is the number of breaks. F is area lost to fire. L is total area lost to fires and breaks. Oh, maybe that's how you do it. You make a function. Do you maybe you express this 50-meter area in terms of one variable that somehow represents like the area of each region plus the area of the breaks, and you minimize that function? Huh. Said half mile break every half a mile. Yeah. There you go. So I guess what are they? What is H here? Oh, that's N. The number. Wait, or is that N? Wait, okay, so B is the area the breaks take up. I would expect it to be the number of breaks times, that's a 2 for half a mile. Times 50 miles wide. Okay. So 25N, that makes sense. F is the area lost to the fire, which I guess we're taking as just one of these regions, which I feel like wouldn't have to necessarily be true, but we could. So what are they saying? F is total area minus area of the breaks over N plus 1? Maybe that's right. I don't know. Area lost to fire. It should be the area in any of the remaining regions, I guess. Oh, maybe I see where this comes from now. So if you... They didn't necessarily say it, but I think the implication here is that every break is horizontal. They're equally spaced. And it's probably all the assumptions that we need. So if you have n fire breaks, so if you have 2 fire breaks, you have n plus 1 many like fire regions. So I think they're doing total area minus area of the breaks to get the area of all of the fire regions, and they divide it by the number of fire regions to get the area of each region. Okay, so I'm on board with their formula there. Then L is total area lost to fires and breaks. Shouldn't that be the total area? Total area lost to fires and breaks. Oh no, just of one of, I see. Just one of those fire areas plus all of the breaks. Okay. I guess this makes sense. If I was just given only the problem and not this work, I'd be very lost as to what to do here. Don't know what you try to do. Best thing in math. So they take the derivative. Yeah, so I mean, I think you just optimize L now. So you take the derivative of L. You have to do quotient rule on this, I guess. That's the result of the quotient rule there. You derive the numerator first. So you get a minus 25 minus. No, you should have a plus 25n up there, right? Let's let Wolfram Alpha do the heavy lifting for us. No, they're right. Okay, I'm just bad at math. How does that work, though? You derive the numerator, you leave the numerator alone. I guess I just shouldn't question Wolfram Alpha. Hey, Thunder. I'm good. How about you? Ooh-wop? You want ooh-wop? I don't have any follower emote slots. I could move one of my follower emotes down, I guess. Use somewhere after months. I don't know how. Yeah. Alright, you know what? Well, let me see what my emote situation is looking like, Thunder. Twing Lockboy, hey, welcome in. How's it going? Alright, that fixes the problem too. Let's... okay, I do have exactly one sub emote slot open. And if you just use your Prime on me anyway, which, thank you so much, I'm just gonna make it a sub emote. There's ooh-up. Image is not square shaped. Oh god, I've gotta crop it. 1 second. Ah, wrong paint. You came from Phobos stream. Oh, awesome. Phobos is great. I better thank Phobos for sending you over. Are you gonna do math problems? Yes. You gonna stream helping them leave? Yeah, zero context. So I'm a little bit distracted right now, but I'm looking through this problem right here that was posted to Reddit. And I'm checking this person's work. I'll leave the problem up though if you want to read it while I do this one emote thing quick. And if you have a problem, please let me know. If you're just here to chill out, that's completely fine too. The background isn't going to be transparent. I don't think it's a big deal though. Okay, how do I want to make it a square. You hear it to ooh up and chill? I'm gonna make it 420 by 420. Because teehee. Oh wait, why doesn't that... How does this frickin' program work? Fixed size. No? Wait. What? Sorry. I promise you I will figure this out. Okay, wait, it's 147 by 169. Okay, I need to make this box way smaller. 150 by 150. And then move it up like there, I guess. Then crop to selection. Okay, there we go. Pull up SQ. Sure. Sure. Okay, I'm almost there, I promise, and then I'll get back to doing the math. Why? Dude, it's taking forever to upload. I have no idea what you're saying, Eldritch. Um... Oh, come on, Twitch. Stop being stupid. Yeah. Images, it is most certainly square-shaped, Twitch. Can't tell me it's not. The plural of type would be Taipei? Only if you're Taiwanese. Oh my god. Twitch. Oh, what your teacher always says the answer is X? Dude, Twitch, I promised you it's square-shaped. Okay, no, this is annoying me now. I know I can figure this out. Hey, warm-hearted American girl. Right now I'm trying to use technology and failing. Oh, it's not square-shaped. My normal shtick is I take math questions ideally from chat and I solve them. I'm currently trying to get an emote figured out quickly. Dude, please. Oh, not ratio, size. There we go. So I'm looking at the problem that's on the screen right now, but I'm taking a quick... I'm not actually looking at it that actively right now because I'm trying to figure out an emote thing quick. So yeah, if you or anyone has a question in chat, feel free to drop it in, and I'll do my best with it. Okay, now are you gonna like it, Twitch? There we go. Oh my god, I finally figured out how to use a computer. It's great. Upload. Okay, it's now there. All right, see ya, Eldritch. You might need to refresh your page, but it is uploaded. Okay, back to doing the math. So yeah, I do math, obviously by name, I guess. Is it what, Dondo Uwap? Oh wait. Oh, I need to refresh my end. Refresh chat. Now will it work? Oh, capital U. Why did I make it a capital U? 20 things have capital. Oh yeah, all my emails have capital letters. Okay. There you go. Thank you again for the Prime Thunder. Okay. So yes, I do math problems. And that's with like low level undergraduate math and below. And then I also will do video game streams, but today is a math day. Okay, so I think I got to the point where I agree with this person's first derivative here of L. We're going to set it equal to 0. Subtract the 25 over, multiply through by -1. Good. 25. Oh yeah, that's neat. That is 101, isn't it? Is it 101? Yeah, it is. Okay. -1 plus or minus h, right? And what? 101 is not a perfect. Oh, it's not a perfect square, but you can't have like a decimal of a fire break. So I assume they rounded down because yeah, 101 is just over 10. Root square root of 101 is just over 10. So if you add -1 to that, you get something just over 9, and -2 would round it down to 9. You should technically verify that it's a minimum, which they do, by checking adjacent points 8 and 9 and checking their signs, and they get negative to positive, which does indeed mean a minimum, right? Must also be absolute min. It is the only local min available. That's not technically true. You need to look at things going to infinity, technically. How does this function look? Isn't it going to be... I mean, it's not going to matter for the sake of the problem, but... Oh, I'm graphing the derivative. I want to graph the original function. Oh, that's quite the function right there. I guess that makes sense. It's like not an absolute min because it goes off to negative infinity down there, but who cares? I might actually tell a person that. That's an UWAP function? Or, I don't know. I always call it UWAP. I don't know, it makes sense in my head, but... UWAP is funny? Alright. Yeah, I guess I don't know how else to say it. Oh, they even check it with concavity, too. Okay. Um... Imagine folklore on my alter ego. I just want to make sure that like my interpretation of this is right. That Yeah, I think I'm fine. A small note on the phrasing. Since n equals 9, about, is only a relative or a local minimum for the entire function, since there are values less than it, but it is the absolute minimum for the part we care about, positive values of n. Okay. I need to take my sweatshirt off. Give me 1 second. Okay. What the heck? Was someone drunk when they were making this picture? Are they supposed to name the rational function? This isn't piecewise thing. Yeah, it's not necessarily a rational function. Looks like a line. This one could kind of be anything. This looks like arctan. And that could kind of be anything. That's not arctan? Oh, yeah, sorry. I meant normal tan. Or I guess I got them mixed up. Yeah. At first I was thinking x cubed, and I was like, well, no, we have the vertical asymptotes. But yeah, you're right. It's definitely normal tangent. Yeah, it does look a bit like 1 over x, but I think the issue I have with it, I guess it'd be like 1 over x plus 1, or there's some kind of vertical shift there. It's not exactly at 1 though, so that's kind of difficult to figure out. On the far left. Linear function. You have a single. I mean, it's definitely going to be piecewise function. So separate functions for different x values. X equals -3. The curve between -3 and -1 could be a few things. The middle looks like a tangent with a hole at x equals 0. And the curve on the right could also be a few things. A line into a negative quadratic into tan into reciprocal graph. That would be my guess. And I guess you could take some test points to know a bit better. But like you would have to really plug in points to be sure, because you couldn't be sure this is like part of a cubic or something. Or you can be sure this is not part of a cubic. Or that this isn't like 1 over x squared or something instead, because it's really hard to tell visually. Yeah, exactly. Quadratic is the simplest. Square root of x doesn't have a horizontal asymptote like that, though. I can't. Neither does like log. So I do think it'd be some kind of rational function. It's just there's a lot of options for rational functions. Must be a few things. 1 over if it's a vertical shift, it'll be I guess like 1 plus 1 over x. Oh, it's also a horizontal shift though, so it'll be 1 plus 1 over x minus 1. So it shifted up 1 and right 1. I mean, if it even is 1, I don't. The line looks a little bit low to be at 1. Let's see what they respond to that though. Oh, does someone reply to this? Let's see what they said. High school integration, huh? Yeah. So learning chain rule and half English. Really? Your math curriculum is all sorts of screwed up, Thunder. That's a really weird order for you to learn things. Because, like, you've done some pretty advanced problems, but you're only just learning chain rule and half angles. It's like half angles, I learned those in a trig before I ever took a calculus class. You hardly get the quotient rule. It's really just a formula you have to memorize. It's a really annoying one, too. It doesn't make sense to me either. The trick that a lot of students use is high D low minus low D high to remember like what order you derive things. Like, wait, isn't it low D high? See, I even can't say it right. Quotient rule memorization trick. Low D high minus high D low, and the D is what you derive. So it's the normal low times the derivative of the high minus the normal high times the derivative of the low over the square of the denominator. Hey, Stories, can you please work through my math paper with me, please? I will try to be able to understand your homework. I'm not going to go down your homework sheet and do all the problems for you. If you have a question you want to see me do, you can type it out there in chat. Or if it's easier, you can put a screenshot in my Discord. But if you're hoping to just have me do your entire worksheet for you, that's not going to happen. I'll explain to you the concept so you can do that for yourself, but I won't do everything for you. Wub is a very good thinking emoji. I'm glad. Okay. You can visually hear the coming from that. Yeah. It's a thinking man's emote. That's some stats stuff, isn't it? I don't really know what's happening in this problem. Need a hotkey to flip your webcam upside down when you're stumped? Oh my god. Yeah, and also just make the ooh up emote appear over where my face is in the webcam too. I got to ones that I clicked on before. Parametric equations created from the greatest depths of heck. Whoa! Heck is a strong word, Thunder. I don't know. No, just make it Cartesian. I mean, there's some things that are Cartesian that are terrible to look at, but they're really clean and parametric. Non-isothermal grain Groth equation, no particles included? What? Oh, grain growth? What grain of what? Some farmer trying to work out how much properties. I'm thinking like a grain of rice or something, yeah. Or even just grain like you know, like wheat. Okay, I have no idea what the answer to this question is going to be, but I'm just curious to look up like what this actually means. Non-isothermal grain growth, like. In metals and alloys. Why is there a gas constant? Because the farmer is always farting. Like constantly. I probably shouldn't click on an academic like article to figure out to explain the concept to me, a normal person. It has something to do with metal, I guess. Where's the gas constant? Oh, it's there. Yeah, I mean, I guess maybe metal can give off a gas or something. I don't know. Hmm. We have a DM. They just said thanks. Okay. Uh, should we go to the math Discord? I haven't been to the math Discord in a hot minute. You have a profit calculator for a game on Desmos. You're super interested in how it works. Let's see. N is the number of plants you plant, A is the number of fruits you get based on chance. At least what distribution is it? Oh, geez. I mean, it looks like a bell curve. I'm not gonna be able to figure out from this abomination of summations. It drops off really fast. It's a bell curve. Does that mean binomial? It would mean like normal distribution. I bet you could fit a normal distribution that's pretty close if it's not exactly normal. Check out the guts Slater. Do you mean like... Oh my god. Wait, so did you make this or did you find this? Comes for a gaming. Oh, okay, that makes more sense. Because I bet a part of why this looks so ugly is that like part of why it looks so bad is because of all these floors. Because I think Desmos is just gonna need them. If this expressed as like a normal math equation, it probably would not be quite so bad to look at. So I mean, like this right here looks binomial-ish, like really complicated binomial, but yeah, I don't even know. Maybe not. Yeah, I have no idea what any of this means. I would need some kind of like notes or something to be attached. You'll just think it's binomial. I guess, yeah. I don't know what to tell you here. The sum from j equals 2n to 5n of 1? What is this summation? Wait, oh, this is all of this thing is the upper bound of the sum also. Of this summation down here. I didn't even realize that. What? You know, I'm just like, I don't know what's happening here. This is very confusing. Trade 700,000 coins and a trade 1.9 million. Okay. Get 2 to 5 fruits. It's just a weird way to express that, I guess. I guess maybe it's because the N is there. Okay. Yeah, fair enough. All right. Geometric distribution it is. I don't know how that actually looks as a graph, to be honest. It's been a minute since we've been on this Discord. Let's... What am I trying to say? Let's see if we can find a question that we can answer. Are they pinging someone specific there? I'm gonna not get involved then. The layout of the Desmos thing, yeah. That's why you need to have like comments on things so like that if you want others to be able to understand it. This is weird how many of these are open just like with like stale conversations. I feel like the Math Discord isn't normally like this. Oh. What is this? Oh. This looks terrible. I don't want to do that. I don't know what multiplying is actually. I'm just gonna leave that one alone. Cosine of pi over 3? Wait, what is cosine pi over 3? 1/2? Why would you write it in such a weird way? Or why would the problem write it in such a weird way? Using the addition theorems? Why can't you just say the roots are -1 and 1/2? Like, why would you need to express this cosine of pi over 3? They're supposed to use these identities? Like, I don't see how... What's the point of this problem? Could addition theorems mean something else? I'm trying to think. Well, what did you send me, Thunder? Oh, you want to help with this question? We can try it. The chord of a circle, center O and radius R, divides the circumference in the ratio of 1 to 3. Oh no. Find the ratio of the area of the region P to the area of the region Q. It's based on radians? Huh. What? Trying to figure out how to start. Um... R equals L theta? Oh, for like arc length? It's kind of easy, Jed? Oh, please tell. Yeah, I mean, I guess you could get the total circumference of the circle is equal to x plus 3x. Funny new email. Oh, God. Or you could say that I'm like 2 pi r over... We don't know what the angle is, I guess. Circumference is divided into 4 pieces, right? Draw the other points. Oh, you get a square in the middle? Yeah, what is the ratio of the region? Huh. I guess I need, yeah, I guess let's go to the whiteboard. This is a big problem. Let's put it right there. I mean, it feels like kind of one of those things where you just like hand wave the actual proof that maybe 90 degrees because it looks like it's 90 degrees, but well, are we calling the sensor O? Yeah, we are. All right, so Jed wants to fill in the other points. And make a square here. So we want the ratio of the area of P to the area of Q, I guess. So if we make our life easy and just say the area here is arbitrarily 1, just because it'll make the ratio come out nice. I guess we would want to say pi r squared. Well, I it don't be then either. I don't know if we actually even need this thing that I just wrote. Look at chat before Jed yells at me too much. Oh, wait, between the center of the chord and the endpoints of the circle? Yeah, sure, Jed. I think I fixed my mic in Discord too. Let me actually check what mic I'm using. 1 second. Okay. Hey.
Hey.
Do I sound okay?
Yeah, you sound great.
Okay, good.
Yeah, so if you were to complete that line that you've labeled R,
Okay.
then it should go through the origin directly to the opposite corner.
Okay. What does that mean now?
That's the diagonal of the square, right?
Yeah.
Okay. So you have the area of the circle is pi r squared, right? You've got the area of the square is going to be, you know the diagonal of the square is 2r, so you can figure out the length of the square, right?
Right.
Subtract the 2, and you end up with 4p.
I feel like I should know the answer based off that, but I'm not connecting the dots.
So you got an isosceles triangle with base 2r, right?
Right.
So now the sides are going to be identical. Whatever you call it S if you want for the size of the square.
Oh yeah, or S, yeah.
So
Next you want this in terms of, or you want S in terms of R. So it'd be 2r squared equals S squared. So S equals root 2r. So that's the side length of any of these, or any of those things. So if we have that, what now?
You basically need the, if you solve that for S squared, right? You're going to get D squared over 2, or R squared over 2, right?
I do?
Or 2, actually not R squared over 2, it's going to be,
Because this is Pythagorean theorem.
Ultimately, you're looking for the area of the square. So you have S squared plus S squared, which is 2S squared. Yeah, okay.
This is just like the Pythagorean theorem. So I meant to say, like, 2r squared is equal to s squared plus s squared, but I combined the...
Yeah, so you get up with, what, 2r, you ended up with 2r squared?
For s squared, I did, yeah.
Right. That's all you need. And the circle is pi r squared.
Right.
So the area of, so 4p is the difference between the area of the circle and the area of the square.
Okay. Uh, 2r squared. And we know pi r squared minus 2r squared is equal to, or I guess they're using x in the problem, so we'll say 4x. Or, oh wait, no, if we're talking about areas, oh, you're right. It is p.
And you're looking for the ratio of p to everything else, right?
Right, yeah, this is just Q. Isn't it? Pi r squared minus... No, no,
P,
no.
no, Q is the,
Like, how do we involve
Q is
Q?
going to be, so if you solved for P,
Okay.
and then Q is going to be pi r squared minus P.
Q is pi r squared minus P.
It's everything in the circle except for P, right?
Wait, but don't we want Q independently of P? Or else we're gonna get a cancellation.
Well, I guess that's the idea. It's like if you're trying to get the ratio of P over Q, then P over Q is going to be that side P divided by Q, which is pi r squared minus P.
You lost me on this, Jed. I'm gonna be honest. I don't know what's
So
happening now.
P is the shaded area, right?
Yeah.
And you know now you know the area of that. You've got it in terms of R.
Right.
Okay. Q is everything in the circle except for P.
Right.
So Q is equal
So
to
you're
pi r
saying...
squared minus 1/4 pi r squared plus half r squared.
Okay.
Right?
Oh my god, not pi to the r. So pi r squared minus 1/4 pi r squared minus 1/2. Oh wait, parentheses.
Yeah, you
Okay.
can use parentheses or not. And you're looking for the ratio P to Q, P over Q. So put P over Q.
Oh. I guess. Let's see how this works out.
I'll leave the long division to you.
Oh, good. It's an
I mean,
exercise
you could
for
bring
the
out the r
reader.
squared. You can bring out the r squared on all these terms as well. They're
Yeah,
going to cancel.
that'll
So you
cancel at
end up
least.
with,
We can also cancel it too. Or 1/2, I guess.
I think once you factor the r squared, it'll be pretty clear. It's going to be like, what it might be.
Thunder says, I think I get what Jed is saying. Okay, that's good news. I think this should boil down to one clean thing. I think we just need to figure out how. Like, it should
Yeah, I
be like
think
3-2 or something.
the circumference thing, dividing it into x and 3x, kind of gives you the fact that you've got a square you can play with.
Yeah, that's fair.
So you end up with that 90-degree slice.
Um,
But now if you just solve that,
that's kind of... I might give this a Wolfram Alpha, because I don't know how you... I mean, technically it's an answer. There should be some kind of simpler form, though.
was it 1/2
I
pi
minus
minus
2
1
to 3...
over
Oh, or maybe not.
3/2 pi plus 1?
Oh wait, I think Bind Thunder's answer agrees. So it's actually okay that we have pies. I thought that we'd have to get them to cancel, but Thunder just they factored out another 1/2 from the top and bottom and canceled those. And that matches the answer in the book. Huh. Actually, that does match, right? Yeah. Hey, no exists on YouTube. Well, sorry it's too late, but welcome in.
Yeah, I think you get the same thing if you multiply by, times 2 over 2. You get the same thing, right? So
Yeah, that's true too.
minus 2 or 3 pi plus 3, or 3 pi plus 2, yeah. That comes out to be basically like 0.1 or 1/10.
Huh. Nice job, Jed. I didn't see that at all. I was gonna go on some really weird tangent.
The Wolfram Alpha's link there doesn't work really well, but it comes out to 0.0999 something.
Okay, it seems like it's really a number, so I guess that makes sense. Okay. I guess I'm happy with that.
Cool.
Well, thank you for the help.
Yeah, it's like I was thinking it's like that the x and the 3x. I mean, it's like okay, well, let's put the other points in there, and it's pretty. You know, if you visualize that, it's like okay, you're gonna have a couple of the chord is basically gonna create the endpoints of the chord will create diameters that match up to that. So you end up with that lovely square in the middle, and then the r's cancel out, so you don't, you know, basically done. But yeah,
Yeah, also in terms of R, that'd be a bad thing, so I'm glad they did cancel.
yeah. This the what Thunder was saying about the angle at the center is pi over 2. It's basically 90 degrees because it is.
Okay, yeah, so
If,
that's what I was
yeah,
thinking at first. Like, there's that theorem that says if you draw the line from like the endpoints of a chord to the center, that makes a 90-degree angle. I forget what it's called. That's where my mind went
not
first.
not always.
Oh,
It
really?
depends on the chord. Yeah,
Oh,
I mean, if you were to have the chord be divide the circumference into x and 2x, you wouldn't end up with a 90-degree angle.
hmm.
I don't know that to be. I mean, consider a chord that is a diameter.
That's true. Yeah.
You know, that's kind of the extreme case, but
Oh, I guess yeah. It would have to be. Yeah. What was that? I wonder where that theorem was then. Because there was one that was like
I
generally
know what you're
true.
talking about.
Yeah.
I just don't remember what the.
What the name of it is? Yeah, I guess it's not important, but yeah. I mean, you might be able to do it with like isosceles triangles. Actually, yeah, you can definitely do it with if you know the right angle is right there somehow, then you can definitely do it near the same way that we did it. So we made a square, but you could just make that isosceles right triangle that we ended up with anyway.
Yeah, you could do that and just do 1/4 of the area to figure out the value of p.
Right, yeah. Oh, math professor,
But
hey. 3 plus x is 2 pi. So x is pi over 2. Oh, okay. That's how you can figure it out. Nice call. Let me give you a save, Jed, as well as to math professor. Also, check out math professor for more math stuff.
Is Thunder's question second question geometry also? I'll stick around.
Oh yeah, let's see.
If not, I'll duck out.
Yeah, if it's geometry, we definitely want you around.
It's easier when you're at the whiteboard to whisper in your ear
Yeah.
than to have to wait for you to, because you still don't have the hey, listen.
Oh, I do need to make that. It looks like it's geometry. You're in luck, Jed.
Oh, good. Fun times.
I need to zoom out a bit.
Where is he posting these? The math homework? There we are.
Brain hurted bad after this one. No, it says I hassled 7 hours math because you didn't learn for your exams. Oh, that sucks. No exist. I'll make a note of that. Hey, listen thing. Okay.
That's a trickier question.
Yeah.
Was that published in your Discord?
Thunder just DM'd it to me.
Okay.
I could copy paste it over if you want to see it for yourself, though.
No, I got a screenshot.
Okay. The answer is a whole number for both. Okay. And there's.
Oh, that's a fun one.
So they give us a sketch, so at least that nice.
Yeah. So we should be able to calculate the values of a and b, given that f of x is equal to g of x at those points.
Yeah. Through points A and B, it meets y equals f of x at point P. We don't know what P is. Just that
So
it's
we know,
below A.
yeah. Well, we can. if we get the formula for the circle, given the midpoint of AB, and we can calculate AB by setting f of x and g of x equal to each other, then we get the equation for the circle, and the circle is going to have appears 4 intersections with f of x, and so we want the one with the lowest x value. We can get the point P.
Yeah, we don't know the equation of the circle. That's kind of the question. We know that
So,
AB will be a diameter and BP must be a diameter too. Might be able to use that.
right, so A and B are a diameter, and the circle has a center M, which is not on the graph.
Right.
So
we don't know
if
where
we
M
can
is though,
figure
right?
out, but we know M is the midpoint of AB because AB is a diameter.
Oh. Yeah.
And actually, it's given M is the midpoint of AB, and the circle is specifically centered on M. So
Right.
we can, if we calculate the values of A and B, then we can easily calculate the midpoint of that line. I say easily, but it's going to be whole numbers. So.
Well, for you it's easy because you get to just watch me do it. So you know.
Note to self: buy whiteboard cleaner.
Well, if you want to make Zach happy, change it to a chalkboard.
Which Zach are we talking about? Short-haired Zach or long-haired Zach?
Oh, I guess it'd be the short-haired one, because I believe the long-haired Zach had a change of heart.
So Thunder was mentioning they had trouble trying to figure out which one was A, B, and P. And I'm just looking at the x coordinates of that. So A and B are both going to intersect, or the intersections of fx and g of x. That'll occur at 2 x values. A is going to be the lesser of those 2 x values. And Hardlocked says your hair looks nice today, Don.
Oh, well, thank you, Hardlocked. I think your hair looks nice today too. Even though I can't see you, I'm sure it does. All right. I guess let's draw this. I don't want to make an accurate drawing though. What's up, Jed?
Give me to read the equations for you so you have those.
Oh, yeah, sure.
Yeah. So f of x is -3 times the absolute value of x plus 3.
Oops. Yep. There's like a plus 15 or something?
Oh yeah, plus 15. Sorry,
Okay.
string play. And g of x is -3/4 x plus 3/2.
That is a crazy 3 I just made there. Okay.
Cool.
Then I'm just going to vaguely draw the function, I think.
Sure.
Line.
Looks good.
Just like that. Thank you. So that was B down there?
B is on the is a positive x-axis, and A is the intersection on the left left.
God. E. Circle's looking a little rough, but you know.
So good.
Your hair is nasty, you hate hair? Well, you know, being bald is pretty cool too. So we want the equation of the circle here. Okay. Well, I guess finding a good start is finding A and B.
Yeah, so if we set f of x to g of x, and then solve for x.
Well, so we need to do two separate equations here because it's absolute value. So we'll take the positive part first. Actually, if we don't...
Can you just simplify it without worrying about the splitting it apart first?
Oh, yeah. Yeah, okay, that's a good call, Jed. Okay.
Less work.
Deal with the absolute value at the very end.
I don't know if that's possible or not, but
I don't see why not. Let's try it and see if we get the wrong answer, I guess. You're not saving me from doing fraction math, though, unfortunately. 3 over 2 minus 15. 3 minus 30 is minus 27 over 2. I think so.
That's what I got.
Okay. Then we divide everything through by negative 3. Positive a fourth. Plus 9 over 2. Okay. Now we can do our flipping stuff. Or whatever.
You're positive and you're negative, right?
Yeah. For x greater than 0. Well, I mean, it's really x plus 3 is greater than 0. I'm just going to not worry that. Who cares? Well, we can say x plus 3 greater than 0. Okay. 3/4 x equals 9 over 2 minus 3. It's 3 over 2? I think that's okay. 3's are going to cancel. X equals 2. That seems like a reasonable. But I do want to plug it back into these just to be sure. So you get f of x is 0. And g of x is 0. Okay, good. Then we stick a negative sign in front and do the same thing.
I confirmed x equals 2 is the correct answer.
Okay, thank you. Did I drop a... No, we're good. So that trick does work with doing the absolute value less, so good call on that. We have 9 over 2 plus 3 now. So 9 plus 6 is 15 over 2. Minus 3/4 x equals 15 over 2. X is 5 times negative 10?
Nope.
Are you sure? It seems right.
It's not. According to Wolfram Alpha, that is not correct.
What is it then?
Negative 6.
Negative 6. I must have made a mistake earlier on then.
You have x plus 3 is 1/4 x plus 9 over 2, and then
Hey,
negative x
SG1.
plus 3.
Um,
Negative x minus 3, bring the 3 over, is 15. Negative x, and this... The 1/4 x, where did you added a negative 1/4 x on the third line from the bottom? There
yeah,
should
why
be a
would I
positive
have that
1/4
there?
X.
It's a good point.
It should be a positive 1/4, right?
Yeah, you're absolutely right. So that'll be negative 5 over 4.
Yeah, negative 5 over 4 x equals 15 over 2.
Does negative 6 work there?
Yeah.
Yeah, okay, good.
Because you make the 15 over 2 30 over 4, so negative 5x is 30, x is negative 6.
Okay, so we now know b
You
is
can
what,
plug
2,
those
0?
into either equation to get the y coordinates.
Yeah. We'll plug negative 6 into that first one, I guess. We'll get negative 3 times 3 is 9, plus 15 is 26. That's 24. I'm going to plug it into that one down there just to be sure, too. 6 plus 3 by 2. I'm not trusting my fraction math. See, that's a different number there.
Negative 6.
No, it's negative 6, that's why.
Plus 3 is negative 3. So you get negative 9. Yeah, so you forgot the absolute value in the top, didn't you?
Well, it's negative 6 plus 3 is negative 3. Absolute. Oh, it's negative. I forgot the negative 3 on the
3
outside.
times negative 3, which is negative 9, so it becomes 6, right?
Actually, that makes perfect sense because how 24 is way higher than 15.
24.
So we're saying this is 6?
Yeah, it should be 6, right?
Okay, and that
9
agrees
halves
with
plus 3 halves
the...
is 12 halves.
Yeah,
6.
it's 6. So I was just about to get to 6 down there too, so we're good on that.
So M would then be the point -2, 3.
Average of those. Yeah, -2,
The
3.
Thunder's asking, oh, shouldn't you get 2 answers to the negative part? So we did. We actually did. We're looking at f of x and g of x, not the circle yet. So we only
Oh,
have
right,
one.
yeah. We haven't even
One.
thought about P yet.
Yeah. So now we can figure out the equation of the circle because we have the center and we have a radius we can calculate.
We have the center. You're right. Okay. That makes life easier. I need to erase the stuff in the middle now. And then we're going to have to equate the circle, I guess, with f of x. And we'll get 2 more answers. Actually, wait, is the equation of the circle the first part of the question already, or what was it?
Yeah, the first one is find the equation of the circle.
Oh, good.
And then the second part was find the area of the triangle APB.
Triangle AP. Ooh, okay. Well, first up the equation of the circle. So our format for a circle, it's x minus the coordinate, the x coordinate of the center. So it's -2, so we do x plus 2 squared plus y minus the y coordinate of the center squared equals radius squared. Oh, we gotta do the distance formula, man. 3, 4, 5. So it's 25. So it's a 3, 4, 5 right triangle?
Yep.
Okay.
I see that as well.
Cool.
So the x is the 4, the y is the 3, and so that makes the hypotenuse 5.
Okay, so that's the equation of the circle, Thunder. And if you're not sure, I just did the right triangle stuff. You can also just do the distance formula between here and here, or between A and M to get what the radius is, and then you square it.
One of those lovely Pythagorean triples.
Yeah. Okay. So, I mean,
now
we lost, yeah, but let's go on to area APB, I guess.
Yeah, so now we can figure out the coordinates of point P if we care about that.
Yeah, and actually, because it's an absolute value function, we can just take this part of the absolute value, and we'll only get one answer as well, which will make life easier. Oh wait, Thunder's asking a question. For the area of the triangle, how do you get the height? I'm not sure yet.
I have a potential strategy for that.
I think we should figure out the sides, or if you want to say your thing, Jed.
So if we were to label the point where f of x hits the negative x-axis as, let's call it Q, for lack of a better term.
Okay.
Then the area of triangle APB is going to be the area of triangle AQB minus the area of PQB. So you could do that.
I think
right.
My instinct is to. It's going to be like AB and BP are both diameters, so it's going to be an isosceles triangle. So I think we won't have that hard of a task to.
Wait. Say that one more time. AB and PB are diameters?
AB and PB are diameters, so...
PB is not a diameter, it does not go through the center.
Oh, you're right. Dang it.
So
we can still get all three... Oh, no, we don't know. No, if we know P, we get the distance from P to B, and then we know all 3 side lengths.
Yeah.
And then we can do law of cosines to get an angle. And yeah, so we'll be able to figure out the height.
Or you could figure out the triangle AQB. Find that area.
Perpendicular from AB to P.
PQB.
Thunder, that's basically what I would do. Jed, maybe? I don't know. It feels a little like backwards though to do like that.
You have to do a little trig if you're going to do try to drop that perpendicular or law of cosines. You get trig involved there.
Hey to Koki Togo on YouTube. That's it, then you have it. Oh, you're okay with the rest of the problem, Thunder?
I'm intrigued to
like, do you know how to get P? So I'm looking at just like dropping it if you're good with it. Just like triggering it. Okay. Up to you.
It can be trig, or you can just use, like I said, if you can figure out the the height of area of triangle AQB, right? It's A. The y coordinate of A is the height.
Y coordinate is the height.
So if you're
Okay,
looking at
yeah.
the triangle AQB, you can easily determine the height of that triangle and the base of that triangle.
True.
And so you can figure out the area of AQB, and you can do the same thing once you figure out the P coordinate with PQB.
Oh, okay.
And then APB is the difference between those two areas.
Okay, yeah, that's not too hard then.
And that wouldn't require any angles or trig or anything. It's
That's
just
fair.
simple. Once you figure out point P, which is just setting f of x equal to the circle, and figuring out the most negative x value where they intersect.
Yeah. Looks like we have an exciting new problem. That is a nice way to do it, though. That avoids dealing too much with angles, though, Chad.
I'm going to plug in that into Wolfram Alpha and see what I get.
Okay.
For that point P.
Wait. Did I not? Yeah, okay, I was like, why does this look so familiar? There we go.
Oh, you have to solve that for y. Ugh.
Actually, we can just zoom in. No, it's about 3, I assume. Ah. Dude, what did I do to my browser? There we go. Okay. You tried and failed on this one? Okay. Diagram shows a sketch of the absolute value of these parabolas. Ooh.
So that x coordinate, by the way, is I'm getting -7 for that. So that is it's still keeping it nice and round.
You're getting -7 for that. Oh.
Or for the last problem, the other intercept, I'm getting an x value of -7, which you can plug into the equation to get the y coordinate, and then so everything is nice and even, which is really
okay.
nice.
That's nice, yeah. I don't think this one. It's one that will be confusing to set up, Thunder, but I think you have to know how to break up the absolute value here. We can definitely do this. This was really cheat geometry, Jed, but you're welcome to hang out if you still want to.
No, I'm fine hanging out. This is interesting.
Okay.
So they have 3 intersection points.
Yeah, it'll be basically like the part of the parabola that's reflected will be the negative part of the absolute value, and the part of the parabola that's normal is just the positive part. So we're gonna have to equate the negatives to the positive sometimes, or the positive to the negative, and like
Yes, good
different
call.
combinations.
Let me know when you're ready for those equations. I'll read them to you.
Oh yeah, please. Okay, I'm ready.
P of x is the absolute value of x squared minus 8x plus 12.
Good.
And then q of x is the absolute value of x squared minus 11x plus 28.
Okay. What are the roots here? Just so I can graph them. -6 and -2. And -7 and -4. Okay. So 2, 4, 6, and 7. 2 and 6. And then at 7 and 4.
The first line bounces a little higher than that.
Oh.
That might help with your drawing.
I'm just kind of doing a Yeah,
close.
you're right. I should make it match a bit more.
Did you want to draw that second one maybe in an alternate color? Just so that it's obvious, like
Okay.
the way the intersections are.
I'll do more work. Oh,
Phobos
who's that?
stream.
Phobos, hey! Thanks so much for the raid. Welcome in, everyone.
Already have 6 inbound.
We're working on this problem from Thunderfix in chat. How's your stream, Phobos? I'm also in Discord with Jed Levi right now. He's been helping me out.
Pay no attention to the man behind the curtain.
We have 2. Actually, oh god. Blue pen, red pen. 2, 4, 6, 7.
Phobos says, it was great
Oh no!
getting
Make
precise
it go
with the
higher.
FTC.
Sorry, what, Jed?
That Phobos said it was great getting precise with the FTC.
Oh, awesome. Glad to hear it. Okay.
Just trying not to get busted for securities fraud, Kappa.
I mean, you know, that's good too. Hey, Brownie Man. Yeah, doing math. All right, so we got A, B, and C for 3 intersection points. We want the exact values of the x-coordinates of the points A, B, and C. Okay. So
Just the x coordinates.
yes, okay, that's a nice thing to remember. So Hunter, anytime you have an absolute value function, you can break it up into a piecewise function, and I think it's a helpful thing to do here. So this left part of the parabola and the right part of the parabola are the normal parabola if there was no absolute value. So I would say x minus 6, x minus 2 goes with that part of the curve and with that part of the curve. It's going to be a really messy drawing. Then the middle part goes with the same thing with the minus sign in the front. And it helps you to visualize it. I'll draw it like separately here. If you have 2 and 6, the normal positive part of the curve looks like that. So the left and right matches with that left and right. But then if you draw the negative version of the curve, that middle part matches with that middle part more or less. Gonna lurk? Well, thanks for lurking, Phobos, and for the raid. Was a natural 20 and lurks amazingly. Oh, that'd be an amazing like command message for when people lurk.
Yeah, Thunder said the negative part is the negative part of the absolute value is the question.
The negative part is a negative part.
Yeah, so the P of x could be the positive x squared minus 8x plus 12, or it could be the negative x squared minus 8x plus 12. And that negative part is where it bounces.
Yes. So
yes, you had that correct, Thunder.
When I say absolute value, you always have like the original thing inside, or the same thing with a negative sign stuck in front. And so the original version goes with the outside parts, and the negative sign version goes with the inside, basically. And hey, skinny columns Windex, Donda's math, welcome in, and hello to columnist column Sherlock. Are you two related, or is that a crazy coincidence? Either way, welcome in to you both. So Thunder, I hope you're okay with this so far. We can do the same thing for the red parabola.
Makes sense. So the part that bounces the negative part. That's it. You can skip the question.
Oh.
So there you go.
Okay. Yeah, if you know like how to equate things from there, then I guess I won't explain to you things that you know.
And the columns are not related.
You don't know each other? Wow. Okay. I guess the columns are got me there, but hello to you both. Okay, so if you're good from there, Thunder, do you have anything else, or are you all good for now?
I shall revert to the shadows.
One question you can't find? If you find it, let me know.
Oh, it's not geometry. I'm out.
Oh well. Oh, Jed actually left. Well, thank you for the help there, Jed. I need to give out saves. And Jed probably got at least 2 there. Thank you for the follow. Should I just call you Windex, I guess? You're saying a fuel tank is being designed to contain 200 cubic meters of gas. The maximum length of the tank that can be safely transported to clients is 16 meters long. The design of the tank calls for a cylindrical part in the middle, with hemispheres at each end. Ooh, gosh, okay. The hemispheres are twice as expensive per unit area. Ooh. If you can do this, you are Himothy. I don't know what that means, but I aspired to be it now that I have seen the word, I guess. Twice expensive per unit area. I think we can do this. I'm trying to work out what exactly is going to happen here. So we need the volume and surface area for spheres and cylinders. Okay, yeah, let's try and work this out. Well, volume was actually, no, let's not make assumptions. I can never remember. It's like 4/3 pi r cubed. Okay, cool. You know what? Let's actually let's do my fancy new command here. Let's make sure it still works. Okay, good, it works. I do need to crop it there. Okay. This problem, it definitely looks fun. So I guess let's draw a picture. Okay, so importantly, the sphere and the cylinder will have the same radius that I guess we can just call r. This is, I mean, I think the calculus is probably the harder part, but it is also a geometry problem. The maximum length is 16. A 10th grader who failed gym was able to do this? Oh, wow, okay. So we can actually express the length of this tank, or like the length of the cylinder, as the total length is 16. Let's actually put that up here. It's the total length is 16. The length from here to here is r. The length from here to here is r. So the length of the cylinder is 16 minus 2r. And I think those are the two values that we need here. So we need the volume to be 200. Okay. Climbing the rope makes it hard to hold a pencil. So, for the sake of the problem, we can simplify things. Instead of considering two half spheres, which is a hemisphere, let's just consider one whole sphere, because two hemispheres add up to a sphere. So we can say that the volume of the tank, is the volume of the sphere, we'll say, 4/3 pi r cubed, plus the volume of the cylinder, which is pi r squared L? Let's verify that. Pi r squared L. Well, I mean, Google calls it H, but HL, who cares? And here it's 16 minus 2r in any event. Pi r squared 16 minus 2r. And we know that they add up to 200. Okay. It's not going to be shorter, right? Because we want to maximize, no, we want to minimize, oh. Hemispheres are twice as expensive per unit area. A shorter tank makes for a bigger radius. Okay, so that's a good point, Jed. I think we can safely do what I did on the board, but we should actually think about that and know why that's okay. So the hemisphere is twice as expensive to create as the cylinder part. So we do want to maximize the cylinder part. So I think we want to make it as long as possible because the cylinder will have more in effect there. Tank could just be a giant sphere. It's true. It's actually, So I do think we want to make our cylinder as long as possible here. Well, if it's r equals 8, there's no cylindrical part in the middle unless you want to call it a cylindrical part of 0, but I think it's against the spirit of the question. Or it's, you might get it as an answer, but it's a result that you would throw out. Hey, Bode. The hemispheres are twice as expensive per unit area as the cylindrical part. That's the issue too, Jed, I guess. It's probably over, right? Because 8 cubed is a number. It's over 200. Okay. I guess let's figure out our equations for the surface area now. Surface area. Our teachers probably can't even do them. Oh no, I don't think I'm stuck, Sherlock. I'm just trying to make sure that we're doing things the right way. We're gonna want it to be one variable though, Jed. Bode, I think I saw those problems, and absolutely not. If they're competition problems, if they're Olympiad problems, I'm not even entertaining that. I'm sorry. They're too hard. Like, or they require tricks I just don't know and I don't really care about. Like, I'm sorry. It's just I'm not particularly fond of competition math. 2 pi RH, and I'm saying h is that, plus 2 pi r squared. You have one equation you're trying to optimize, one equation that gives L in terms of R. Yeah, like, or I guess for the purpose of the question, you're not in a multivariable calculus class, right? Because, that might make the problem different. I'm assuming they're in a single variable calculus class, which you need things to be in just one variable. But yeah, Jed, what you said is right. I eliminated the extra variable by making it in terms of R. This, it's the two ends of the cylinder, Jed. 2 pi r squared for surface area. Can you look at the and hey, Broccolo, can you look at the if a hemicircle or cylinder area grows faster, and then just make the tank with either a mega long cylinder or a big ball? Yeah, I mean, I think it's going to be a mega long cylinder, which is why I did the 16 minus 2r thing. We still need to actually compute the value, though, right? I guess you still need to find your radius that you want. Oh, okay, that's a good point, Jed. This is the general equation for the surface area of a cylinder, but we don't have the ends in this case because, yeah, we want to chop off that part. SA sphere, I need to Google. Sphere. 4 pi r squared? Okay. Thank you, Jed, as well. That's so, it's just 4 pi r squared? That feels like cheating. It's like how a cube has, no, never mind. A cube has 4 sides. It's not 4 sides. Don't listen to me. Okay. So total surface area. I'll say surface area of the tank. Are these two combined. So, you know, it's kind of a 2 pi r squared. It's just a 4 pi r squared, Jed. That's really r? I guess if it was r squared, you would get volume. Okay. But that's the one. Okay. Plus 4 pi r squared. Okay. Wait. Jed, you might be right. So you can just solve this for r and you're done. Can't you? Okay. You know. So I just realized you can just solve this equation for r and you'll be done, technically. So I do think it's L, and you throw, okay. About the Jed, you might be right. We do have to sub the L out. So we do need to be in one variable. I was just jumping the gun a bit because I don't know. Okay, so it was leaving me to say that the entire thing is 16 long. We're just gonna say the length of the cylinder is L. Then we can say the entire length is L plus 2R, and that it's less than or equal to 16. I don't know if we are gonna, we won't need that until the very end though, if we ever do need it. So long as the tank is 2 pi r squared L is equal to 200. And so I didn't want to do this at first because I don't want things to have two variables, but we'll be able to deal with it because we'll be able to solve this for R or L and sub it out later. So I do need to fix this to be L, and I need to fix that to be L. L plus 4 pi r squared. Okay. So This is the part that it's getting a little bit tricky to me. If we say C is cost, you pay per the square unit of surface area. Hey, Jesus, you found the geometry problem? Oh gosh. Jesus, cosine squared minus sine squared, knowing that TG is 2 over 3. Hey, Yanis. What is the TG part? Cosine squared minus sine squared is a it's an identity. I think it's like cosine of 2x or something. I'm not sure. I'm not sure what the question is though, Jesus. Like, what's the TG part? So, oh shit, I came back to read checks. I wanted to read the problem. Determine the radius and height so that the manufacturing of the tank will be minimal. So I think for the cost, since the hemispheres are twice as expensive and you pay per the square unit of area, we're going to say that 2 pi RL costs 1 for the sake of the ratio here per square unit. Like I'm not really writing the units here, but, and this is going to be 2 times the hemisphere, so 8 pi r squared. And I think we minimize this function now. Yeah. I think it's the intention of what they want us to do here. We do, so we want to minimize this function, but the L is ugly. We don't like it in a single variable calculus class, which I assume that you're in. So let's take this equation up here and solve it for L in terms of R. L is equal to 200 minus 4/3 pi r cubed over pi r squared is good enough for me. So let's plug it in down here. 2 pi r 200 minus 4/3 pi r cubed over pi r squared plus 8 pi r squared. Oh, it's tangent. Okay. Hey, Fembucks. I'll have to get to that after this one. I'm not sure exactly how that one's going to work. Let me get through this problem, though, and I'll think more about it. Okay. This would benefit from some simplification before we derive it, though, so let's actually multiply that 2 pi r in here. Because the pi r will cancel the pi r squared, at least somewhat. So we'll get 400, because 2 times 200, 2 times 4/3 is 8/3. Pi r cubed. Then the pi r cancels the pi r, and we have just 1 r left over. Okay. Yeah, we could actually get a common denominator here and here. Is that overkill? That's probably overkill. Let's just derive it. So let's get C prime. Derive this is a quotient rule for the first one. Derive the numerator first. Get minus 8 pi r squared times the denominator minus, derivative of the denominator is 1. So just the regular numerator over the denominator squared. That derives to 16 pi r. Inflator, thank you, Jed. Inflator, I see that you DM'd me too, but since I've helped you with a few problems, I'm gonna look at the other people's first. And if you have to leave, then I'll DM you back, I guess. All right, so we set this equal to 0, and we solve for r. So I guess let's multiply everything through by r squared to get rid of that denominator. So to have minus 8 pi r cubed, because r squared times r, minus 400 plus 8/3 pi r cubed, right? Plus 16 pi r cubed equals 0. Okay. We have pi r cubed, pi r cubed, pi r cubed. Let's combine like terms. Negative 8 plus 16 is 8. 8 plus 8 thirds is 32 over 3. Minus 400 equals 0. Watch them not give us a perfect cube. 32 over 3 pi r cubed equals 400. R cubed. Oh, it's definitely not going to be perfect cube because we have pi in here. Did we get a cancellation with 432? We do. How many 4s are in each of them? 8 is in each of them. Oh, you like this question, Broccoli? Yeah, I think it's cool too. Wait, 32 is a power of 2. Duh. I just shouldn't do mental math, right? I shouldn't be allowed. 200 over 16. 100 over 8. They both have 4s. 25 over 2. Okay. And there's a 3 that comes up to the numerator, so 75 over 2. Over 2 pi. Okay. So R is the cube root of that bad boy. And I think that's the meat of the problem done. You got minus 5 over 13? Okay, we can try and figure it out. The radius and height, so that's the radius part of the question. We do need to get the height part of the question. And we can use this formula right here. I called it L. I guess I should have called it H to match the problem, but it's all the same. So let's plug what we got for R up into this, and that'll be the problem. 200 minus 4 thirds pi. That's R cubed. That's a cube root, so let's just get rid of the cube root. Pi, oh god. 75 over 2 pi to the power of 2 thirds? Ta-da, that's the answer. Let's not simplify this because it looks terrible. No, it's, we can do this. The pi's cancel up there. You get 2 times 25 is 50, so 150? I had to make a mistake there, right? No, I think it's 150. How does the bottom simplify? It really doesn't. I guess that's the answer. I feel like that's kind of terrible. Maybe Wolfram Alpha will simplify that in a bit of a cleaner way. I'm worried that I did something slightly wrong if I'm not getting a cleaner number, but sometimes with these problems they do just give you ugly numbers. Oh god. Oh god, not ampersand. Thanks, Fembox. I know I kind of like Stuckey's attitude of saying I don't get paid enough to do algebra, but I do kind of like these optimization problems, so. It's equal to 25 over the cube root of 6 pi. Oh wait, I mistyped it. 75. Okay, yeah, it's not much cleaner at all. So I guess that's the answer. I mean, the answer that I got at least. I'm pretty sure my process is right. I might have made some kind of small arithmetic mistakes somewhere in there, but let me know if you have any questions about what I did. In the meantime, let me start looking at Jesus's question. It's wrong? Okay, as far as you can tell, Fembox. Well, what's the answer supposed to be? Hey, Brian. How's it going? Oh, the units. We don't. We're doing math. We don't use units. Actually, did they give us some stupid units that I didn't convert? No, it's all meters. Yeah, exactly, math professor. That's half a Markov, yeah. um ChatGPT got the same answer. Or now I feel like I'm wrong because ChatGPT is like always wrong. I don't trust ChatGPT for much. That's kind of weird. We got the same answer. Maybe ChatGPT is actually right. You made a ball roll down 2 ramps in Unreal Engine. So this game for if you could figure out something like only up, where it's basically an asset flip, you're in business. So what's up with specifically being about ChatGPT? I sure do. Oh yeah, so cosine squared minus sine squared is cosine of 2 theta. If we given tangent is equal to 2/3. That's my opinion, yeah. It really is. I can't say I have Parabola. Arctane of 2/3 is definitely not unit circle. So Thunder put a question, or Thunder put an answer. Let me try and figure out. Tangent of 2 theta. Where does that come from? This? Oh, yeah, it's this. Trying to make a function-based marble course. Ooh, okay. What does function-based mean in this context, I guess? Find tangent 2 theta and work with that to find the answer. That's a good strategy. 5 sine of 2 theta is equal to 12 cosine 2 theta. Oh god, Twitch chat isn't the place for math typing. Just draw right term with y equals 2 and x equals 3 and so. Oh, that's probably a much easier way to do it, Fembox. Oh, wait, yeah. I like Fembox's way more. Wait, I can't talk. Starting to give private math tutoring next week and you're kind of nervous? Oh, yeah. Good luck as well. I mean, when I tutor people, I just straight up Googled stuff. It was like, I don't know the answer to every question. I promise you I can figure out what the explanation is and explain it back to you. So, I mean, if you're private tutoring, it's a little bit trickier because if you're spending all your time on Google, like that's not something I'd want to charge someone for. Like, I'd probably like reduce the hours or something because I'm paranoid about it. But I guess what I'm trying to say is, don't be afraid to say that you don't know something immediately, or to Google it, or even if you have to like get back to them, because it's kind of tough not being in the classroom, knowing exactly the way that students are taught things. or what exactly the curriculum was going to be. You just kind of suddenly come to you with a question. It could be a lot of things. So so if you are still here, I'm gonna demonstrate Fenbox's solution here because I think it's the most elegant one. What Thunder put almost certainly works, but it's also a lot of trouble. But what Thunder did is probably what I was going to try to do. So not hating. Students smell fear, just be confident. Your problems have to solve are kind of scared to get to know the students in front of their parents who have expectations. Oh, fair. Parents need to leave the room? Ooh, interesting. Like, I haven't private tutored. I private tutored a tiny bit online, but most of my tutoring experience is from working in a tutoring center, which is a little bit different. So, the problem here, we're given tangent of theta is equal to 2/3, and we want to know what cosine squared theta minus sine squared theta is, right? Right. Okay, so I haven't seen you type anything in a minute, but I'll still do a problem anyway. Oh, hey, Anas over on YouTube. Let me read your question before I do this one. P is constant. Function y equals BLV. B is a constant. The variable v depends on the variable L. The change is not constant. It seems like a physics problem maybe distilled for me on us. I would say, since b is a constant, you're all to take that outside, which you probably understand. But if L was a function, the variable v depends on the variable L. It's because of that L and v are dependent on each other, that you can't take the length L out, I think. Because if velocity is changing, that means L is changing as well. So it's not a constant. Understand whether integration variable function adds the values of the function or does something different. In a way, it adds the values of the function, but it creates very, very narrow, arbitrarily small rectangles that are based on the height of the function, which is the value of the function. So it's like you're adding up the actual values of the curve, but you're also multiplying them by some, very small number. Or take students of parents in the room either. That's not a role I ever would have thought of, so that's interesting to hear. Tutor but online, the guy treats you like a friend, he swears and makes jokes. Oh, nice. Yeah, it sounds like the tutor's good at establishing rapport. So yeah, what Fembox is saying that we can do here is we can draw a right triangle. If we call this angle theta just arbitrarily, we know that tangent is opposite over adjacent. So opposite is 2, adjacent is 3. By Pythagorean theorem, the hypotenuse is root 13. So now we just take cosine, we square it, we take sine, we square it, and we have our answer. Okay, that's a really nice way of solving this. So cosine of this is adjacent over hypotenuse, which is 3 over root 13, and we have a squared. Sine is opposite over hypotenuse, which is 2 over root 13. We square it, we subtract them. We get 9 over 13 minus 4 over 13 is 5 over 13. I think that's what was being said before. Do we need to worry about the signs of this, though? If tangent is positive... Oh, no. Well, it's cosine squared and sine squared. So we don't need to worry about what quadrant we're in, I don't think. Thunder, I was about to do it the exact same way that you did. Until Fembox pointed out that method. You know, they relate many things to the area under the curve from, and we extract many relationships. I find it a little difficult. Yeah, no, so that's a really it's a really difficult thing for me to wrap my head around too. Kind of the physics explanation is or like how I like to relate like calculus and physics in like a very basic version is it's with position, velocity, and acceleration. So let's say you have a position function, f of x, let's just call it. If you take the derivative, you're taking actual values of the function. Actually, let's call it f of t to make it more clear that it's changing with time. F of... Actually, I don't want to use this definition of a derivative. It'll be a bit more clear with the other definition of a derivative. Limit as what? T approaches a of f of t minus f of a over t minus a. On top, our units are, you know, some like distance, we'll call it meters, because it's position minus position. On the bottom, it's time minus time, so I'll just call it seconds. So we're taking something that was already in meters and we're dividing it by seconds, which is just like velocity. I guess I'll say v of t. And if you do the same thing here with velocity, you do the limit definition of derivative, you're dividing by time again. So now you have meters per second because it's velocity, and you're dividing by seconds again. So that's how you get the meters per second squared for acceleration. And when you integrate, you're doing the reverse direction. So if you integrate acceleration, this acceleration is meters per second squared. You're multiplying by dt, which is just a difference in time, which is still just seconds. So that's kind of like how I think. I like to track the units as like things happen with the calculus like operations. And when you integrate your acceleration, you of course get velocity, which is just meters per second. So that's kind of how I think about it. I don't know if that's helpful for you. That's kind of how I like to think about it. Yeah, Storm, I think your way works, and that's what Thunder was doing. It's just kind of, I think the right triangle way is just a lot easier though. So honestly, I hope that kind of at least helped you a little bit. I'm not the best at physics, but that's kind of like, if I do think about physics, that's how I think about things. Oh, it's 2 theta? Oops. That's not good. Do you wish to challenge the circle? I don't know what that means. No worries, enough. I hope I was helped you a little bit with that. Okay, so I think we've gotten to the bottom of all the questions that were from chat. So Thunder, I think I kept you waiting for long enough. Do you want to? This thing you DM'd me a while ago looks like a bra. Right? Right? Oh wait, I'm not showing my screen. Like, sorry to have kept you waiting. Okay, so this is the circle that I'm challenging. This made brain big hurt and you skipped. Okay. The diagram shows a square ABCD with side length R and 2 arcs of circles with centers A and B. Okay. Show the area of the shaded region is r squared over 6 times 3 root 3 minus pi. I would say kind of give you the answer rather than making you solve for it. So, Jed summoning ritual. If Jed wants to hop in, you are here? Okay. I mean, I don't think this will be too bad at all. Wife's birthday probably should at least say hi. I mean, I guess that's reasonable, Jed. This might not be the worst thing. So I think you can pretty easily make the claim that each of these circles are a quarter of the entire circle. You can make some argument about taking the entire square, subtracting out the inside part, and you figure out this bottom part. Like, oh god. If you can work out what the intersection of these two is, 2r, you can do this problem. And I think you can. Can you? If you do want to hop in for this one, Jed, actually, I'll just hang out in the live channel. You hop in if you want to, and no worries if you don't. Look at the answer. It's crazy. Okay. Are you still here, SG1? Thanks for hanging out with me.
I'm looking at
Oh.
this. And
Sounds good, Jed. Oh god. What did I do? Okay, there we go. The music is good for slaying half demons. I'm glad.
you have that intersection area at the bottom, or the mutual exclusion zone, if you want to call it that, is the part that's tripping me up right now.
Yeah, it's like I see, like if you just subtract out a quarter of a circle, like each of the quarters of the circles, you're subtracting out the area twice. Which it's kind of tripping me up. Like I thought it'd be easy, but it might not be to deal with.
So what might be a possible solution for that is calculating what the intersection of those two circles would be. Subtracting that from 1/4 of the area of one of the circles. That gets you one of the shaded areas, and then just double that. Because then you don't care that area between. Can you label that point in the middle as well? Like E or
Yep,
something?
but it's just an N. Thunder did apparently send the scheme, but I kind of want to see if we can work it out first. Split into
basically
two
trying to-
rectangles. Ooh.
Trying to ignore that segment, that section CDM.
Oh, the Thunder saying we should take a look at the answer scheme. I guess let's do that. Oh, looks like math professor's idea matches the book's idea.
Okay.
So split them into two rectangles. That's at least a part of the answer scheme, I guess. So I guess we can call the midpoint F, or the intersection point F, just to match the book scheme. They draw the straight line from B to F, and they... How do they know that's root 3 over 2R? Because...
Yeah, because AM is a radius, BM is a radius, and AB is a radius. So yeah, that is an equilateral triangle.
Oh, that's the height of the equilateral triangle. No, AM is not a radius.
Here it
A
is.
is on the edge of the circle, isn't it?
AM is a radius of circle centered at A.
Oh, I was... Never mind. I see. Yeah, never mind. I was getting my centers mixed up. I guess let's start doing this. I don't know exactly where it's going, but let's start doing it.
I mean, you could probably do this with some calculus as well.
I was just thinking that you get the equation of the circle and integrate it. That's definitely not what they want you to do. It's a funny idea though.
Approach.
Hey Mina, the problem is that all of my mind is with integrals as quote proof with geometry. I guess that's my assumption, but yeah, you can definitely do this with integrals. That's what I would want to do. Okay, so what we did is we took from B to M and from A to M. Notice that these are both also R. So it's an equilateral triangle. And by Pythagorean theorem, you know the height is root 3 over 2R, I guess. Okay, I can buy that. And so that makes that bottom portion R minus root 3 over 2R. How does that simplify? I don't know if this is actually even important to do. Okay. Oh yeah, thanks Pinbox for pointing that out.
Yeah, I was completely looking in a different direction. I was looking at doing integrals of one circle over another circle to get basically that white region at the top doubled.
Okay.
Or you could do it just single, just depending on your terms of integration. You could figure out the area of the region ABM, the actual ABM white region, not the triangle. Once you figure out that area, you could subtract it from 1/4 of the area of one of the circles to get one of the pink regions, and then you double it to get the pair of pink regions.
You can easily solve it now with basic geometry. You can, Bo. Maybe can you share with the rest of the class? Because I don't see it.
Thunder's still a little confused. What part are you confused on? The equilateral triangle part?
Oh, so I can draw that up more. So if that's A, B, M, I made that equilateral triangle there. I'm just assuming this is the part at least, because I haven't done that much else. Just to get it, we're getting the height of that triangle. So that's what the book did. The white area is next to the equilateral triangle.
Yeah, the area.
Oh, the parts of the circle? That part was what I was trying to figure out.
But still in the ABM, yeah.
So yeah, the curved parts, I'm not sure yet.
Bode is giving some tips here. Make D half of AB. And then name the arcs.
Make D half of AB.
I'm guessing D is the midpoint of AB. Actually, D can't be the midpoint of AB because D is already a point on the square. So we call it something else.
Yeah. So we have it, area ABD equals area.
Yeah, he's actually, Bode is basically saying name the arcs AM and BM.
Squared. So name the arcs AM and BM. Okay. So AM and BM.
Waiting further instruction.
Oh, can we figure out the angle here? And work out what the arc length is? I don't know if that's... Well, we just need the angle. No, that's not... Actually, yeah, because that'll give us the curved part across. If we work out the angle between AB and BM.
Oh, and then subtract one of the equilateral triangles because it's been duplicated.
Yeah, we'll have to do that too. Okay. I think I might see the idea now, Bode. ABM plus one of the arcs. Is equal to 60 over 360 pi r squared. ABM plus one of the arcs. Do we know? Oh, it's equilateral triangle. Yeah, so yeah. That right there is a 60-degree angle.
Okay, so like in circles centered on B, the region between from B to A to M in that circle is the 1/6 of the area of the entire circle.
Right, because it's a 60-degree angle.
Right, and then the same holds true for the circle centered on A, that the arc from B to M is the volume of the area of that is 1/6 the full circle again. See where we're going there.
All right. Thank you, Bode. Let me give you the save before I forget. Same for AMD, the weird shape DAM. I haven't gotten to the rest of the problem yet, I guess.
Okay, so using arc, the sector starting at center A, going from M to D, that will be a 30-degree angle.
Sorry, Jay, can you say it again?
Sure. The area of the sector on the circle centered at A from M to D is a 30-degree angle, so that's going to be 1/12 of the area of the circle.
Yeah, I'm not sure how we're going to use that yet, but that's true. I guess we're going to have to subtract out that. If we can figure out that just that little curved part, Oh yeah, we figure out just the little curved part, and then we can use what you said. Okay. God, this is a lot. So the area of the entire sector, let's just look at like, centered at B going. Just to make it clear what's happening, we're getting the area of the sector. I'm going to focus on this one right here. So it's the equilateral triangle plus the curved part. Is this 1/6 pi r squared? We want to figure out the area of just the little curved part there without the equilateral triangle, because then we can look at the arc length centered at A down here, but we would need to subtract out that curved part. So let's focus on this curved part. So let's focus on this part on the right here. Okay, I guess I see it now. So then I guess curved part, for lack of a better word.
So could you maybe off to the side expand that section and label those? There's like, I guess, 3 or 4 different specific areas we're dealing with.
Yeah,
I'm a little lost on that part. There's just so much overlap going on.
There is.
Like we could name it like region 1, region 2, region 3, or something like that, or sector 1, sector. Or...
Yeah, it might be good to do a boiled down version of this.
Without the shading and all that other stuff. So we have like.
Say 1, 2, 3. Okay. What we want is region 1. All we know how to get using the area of a sector formula is basically 1 plus 2, because we have to use a straight line as our border. Right. And that equilateral triangle forms a straight line. So if we can figure out the area of 2, we can subtract it out to get just 1.
Gotcha.
But then we can't figure out the area of 2 on its own unless we figure out the entire sector area. Oops. 2 plus 3, because that's the entire, BAM sector here. That's like the entire equilateral triangle plus the curved part. But we can still, we know what the entire thing must be. We know what the equilateral triangle is, so we can solve for just 2. If that makes sense. You see how to solve it now?
Okay. I see it now.
Hey, oh, hey, Bob, can we integrate, please? It'd be nice, but no.
So that sector AM, what AM B, or I don't know how you denote sectors. The B is supposed to be the middle coordinate. Is 3 plus 2. The region's 3 plus 2.
Yeah.
We know what the area of 3 is.
Base times height.
Actually, can you make region 4 the area between the triangle and that section between B and M that's outside of the triangle?
Yep.
Wouldn't the sector, I guess the sector doesn't include section 4, does it?
No, it doesn't.
Okay.
So just the curved part is the entire sector, 1/6 pi r squared, minus the area of the equilateral triangle, 1/2 base times height. 4r squared. Let's can factor out an r squared just for fun. Not really important though. Okay. So
that's the area of region 2.
Exactly, yeah. And Thunder, I initially you see how to do it from here. I want to see the answer now just for my own benefit, but I'm working out the entire problem. How you can do this with integration? Much easier. It's actually integration isn't that trivial. It's just easier for me to set up. I mean, I can't figure out how to do it until I'm done with this though. What,
Math
Jed?
Professor has a comment. I think you're missing a 1/2 in there for area of a sector.
I am? Missing 1/2 of the area
I
of the
don't know.
sector.
That's
The entire area is pi r squared. The angle is 60 degrees. Isn't it 60 over 360 times pi r squared?
I think it looks right. I'm not sure where the 1/6 pi r squared does sound correct for the sector ABM.
Only for an area, if the sector is half the angle times the radius squared?
Why would it be half?
Half the angle. Let's look it up, I guess. I feel like it should just be a straight fraction of the entire area.
Well, I mean, we kind of are. Like, if we're measuring in radians, the angle is pi over 6, right? Or pi over 2 pi divided by 6 would be pi over 3, and then we divide that by 2, we get pi over 6.
Yeah. So I was using this formula here. I think we're okay.
Yeah, theta's in radians there, so we're using 60 degrees to say that's 1/6 of the circle. Whereas if we use 2 pi, then it would be half of that pi.
Oh, yeah. Or
half of the radians, because you're measuring radians in 2 pi instead of just 300. So
we're using degrees, so we're fine. I'm trying to figure out why for radians you have the 1/2, but it's not really that important, I guess. I think I would just divide it by 2 pi.
Radians.
I think it'll work out. Yeah. Oh, I guess they simplified it? That, I don't know. I would just do pi r squared and then times the angle in radians over 2 pi, I guess. I'm off somewhere with a 1/2.
But we haven't even gotten to the. We're just solving for section 2 right now. We haven't even gotten to
it does create the final answer. Really?
Section 1.
Huh. I want to put it past me to mess up something simple.
What is that pi over 12r squared minus root 3 over 8r squared? What is that the area of?
Shouldn't it be pi over 6 r squared? Oh wait, maybe you have to multiply your final answer through by 2 if you only got the area of one of the regions? Or I'm not sure. I think I'm gonna. I don't see where the error is here, so I'm gonna continue with it.
Sure, yeah. So we've only found region 2 is what is basically calculated. Now we have to solve for the sector that includes region 1 and region 2. Subtract out region 2, and what we're left with is region 1, and then we can double that to mirror it across the other side. And so we're not quite there yet.
So sector DAM, DAM. So that's a 30-degree angle because 90 minus 60 is 30. Pi r squared. 30 over 360 is 1/12. Then we want to subtract out. I guess I'll say region 1. Is that what?
Yeah, region 1 is that
Yeah.
sector minus region 2, right?
Factor out the r squared again. Actually, how does the final answer? Yeah, we'll keep the 1 over 12 on the outside as well. Or no, that makes it look weird. Just factor out the r squared. Deal with the rest later. Pi minus 1 over 6 pi plus root 3. Did I factor that out right? I think so. One 6 pi plus root 3 over 4. seems a little weird, doesn't it?
Should have
Wait, that's not... What the heck did I do?
1/12 minus 2/12 would be negative 1/12, right?
Yeah. Oh, yeah, yeah. That still doesn't feel right. I need to look at the What does the answer say? Oh, well, if you just factor out a 12 for fun, I guess, or 1/12. And put the root 3 first. You get 3 root 3 minus pi, and that matches with half of it.
Right.
So
we have
then-
to duplicate it for the other half, the other shaded area. Because we just did region 1, we need to include region 5, which you haven't labeled.
Right. No, region 5 is down here. I'm gonna make that region 6, just to be a smartass. No, we'll say region 1. 6 with my terrible naming scheme is 1/6 r squared.
Instead of going clockwise around M, you're
Yeah, it's not a good scheme, but it's mine. Yeah, there are a bunch of regions. Jeez.
Do you want to show the integration route?
I know Bob said it's actually not easier, and I kind of believe him. I see. It seems like I mean I didn't know how to do it until, I mean this is a group solve. Math professor saves Jed, Mbox. Many saves. I already gave Bode their save.
Sounds becoming Oprah.
I'm shady there at the bottom.
You get a save. You get a save.
Yeah. Saves for everyone. Probably need some trig sub that you forgot. Yeah, I was thinking if you do it in polar coordinates, you could treat one of the radius as like the inner radius and the other one as the outer, and it might not be that bad. But you have to find equations for these circles in polar, I guess.
If you were to stack the circle, or stack, another square like this above, kind of reflected over AB, you're going to have like a half circle and another half circle, and where they intersect.
It'd be like an oval almost, right? Oh, those aren't a half circle though. It's some weird shape.
If you reflected the entire shape over AB, then you'd have half of the circle centered at A, half the circle centered at B, and where do they intercept? That would be the white areas in the middle.
Oh, that's right. Okay, yeah. You're going to sleep, Thunder?
Calculate
All
that
right.
area. And
Thanks
then you have
for the
half
questions.
the circle centered at A, and if you subtract out the intersected area, you end up with the answer.
I guess so. Hmm. Okay, but I was interesting per problem. Yeah, it's from Thunderfix there, who just went to sleep. Well, I guess that's it for the problems from Thunder for the day then. Anything else from you, Jeb, before I go look around on the internet?
Thanks.
All right. Well, thanks for the help.
Yep, always.
Okay. You have some idea of the problem in your high school competition. Oh, really, Bob? God, okay, the integral. I don't know why I shouldn't be interested in it, but like I'm kind of interested in figuring out the integral way. Sounds good. Hey, corrupt. K is I plus J. P is I minus J. Isn't it 2I corrupt, or am I crazy? Let me research what's on the board, and then we'll figure out what we're going to do after that. Ugh, this thing is getting sprayed. Okay. Oh, it's non-commutative. Oh God, what? Oh yeah, you were talking about, or someone was talking about like some kind of non-commutative addition at some point, weren't they? I don't remember. You had to break all the rules again? Yeah. Okay. It's not 2K? Oh my God. I don't want to do that type of math. Problem is, S is defined as the set of all z such that the absolute value of z is less than 4. And 2 root 3 minus 2 is less than or equal to the real part of z plus the imaginary part of z is less than 4. Find the surface of the area. What? The volume of S? Okay, S is 3. Wait. Is this some kind of three-dimensional complex variable stuff? Like, you have the real axis, the imaginary axis, and a z-axis? Is that... There's no way. Or how's this a volume? You get a 2D shape and a coordinate system. Okay, I'm not... Are you talking about the area then? So I was thinking like three dimensions because you said volume, but it might be like a translation issue. Area? Okay. No worries, Bob. um, so the modulus or whatever of z being less than 4 just gives you a circle of radius 4. But then the next constraint, like the real plus imaginary part is tripping me up because the modulus is root, real squared plus imaginary squared. But real plus imaginary on its own is just something else that I don't know how to interpret. You didn't manage to solve it? Oh, okay. I'm assuming it's going to be a hollow circle of some sort. I don't really know though. Like, like you have the big circle radius 4 and then some kind of inner circle based off that real plus imaginary part. I don't know. It's not as simple as 2 root 3 minus 2 though. It's gonna be a strip in the circle? Really? What does it mean for the real part plus imaginary part to be less than or equal to 4? That you can either... It does? Because the real part could be 4, and the imaginary part is 0. The imaginary part could be 4, and the real part is 0. Which... that give you like a line? Oh, okay. Maybe I just got there. Okay. Okay, so it's a diagonal strip, I guess. Okay. So you could just make this into a normal geometry problem. Now that we know the geometric interpretation of these, I don't know how you would do it still. You can break it up into like a trapezoid plus two, I guess like curved parts we've been calling them. I guess that's a similarity right there. Like the potential similar, so I guess I see why it would remind you of that. If you're still big math noob, knew very little about math, yeah. Well, you're an expert on any problem that involves cows, Bob. That's pretty big progress there. I feel like there's a polar integral in there. At least for the curved part. I can't quite work it out, though. Cowboy, cowbob. Two pairs of parallel lines, slopes 1 and -1. So a circle radius 4, or is it radius 2? Oh, radius 2. If the modulus... No. Radius 4. I think it's already square rooted. The circle would have the equation would have 16, I think. Tell you that integrals were not thought before the exam. Oh, it's meant to be solved geometrically. Okay. If you're good with spherical calcs, you'll do well in physics. Yeah, glad we... I guess that'll be pretty similar to this problem if you're trying to solve it geometrically. It's gonna annoy me. Like, how do you get those curved parts? Oh yeah, Hanyo, we actually worked out this problem that I'm showing right now. It was a pretty interesting one. I erased it already, unfortunately. Bob put a similar question in chat that I've been thinking about. I don't know why I solved this one up though. Yeah, I would show you this solution, but we already erased it. You make an equilateral triangle from with A, B, and the intersection point, and you can use the area of sectors to work out like from B to the intersection up to A. Subtract out the area of the equilateral triangle, and then you can do the sector from A to the intersection down to D, and subtract out that little like curved part in there, and then you're good. Do you make a triangle similar to what you did here? Yeah, that's an interesting problem. I don't have any more DMs on Reddit. I want to go to the math Discord. You have your dynamics of machines mid-semester in 1 hour, feeling a bit nervous. Oh, geez. Well, good luck. Dynamics of machines. Oh, God. I don't want to do this. Sneaky sock picture in here, too. Don reads it, yeah. This I haven't done it as much in the last few weeks, but this is how me going through Reddit looking for questions off the internet has been something I've done a lot. Oh, Bobby just sent me the diagram of it. That's kind of an annoying problem to have to do. I mean, it's an annoying problem to have to do in general, but like especially geometrically. So yeah, that's what I was imagining in my head after you guys pointed out these are lines to me. Try your problem, have fun. Yeah, I definitely don't know about that one. Corrupt. See, like you can definitely make a trapezoid to get the most of the area. That's just the little parts that are outside of the trapezoid that are, I'm not sure. It looks pretty associative. It's kind of math language that I like. All right, and I probably should. I feel like I could figure out how to do this one. It's oh, playlist just looped. Let me get some new music. I hope the music hasn't been skipping, by the way. I think I fixed it. Actually, I would be able to hear it if it was skipping with the way that I have it now. Okay, never mind. Yeah, I was given to Baba as a complex number problem. I don't know how you would, but probably the intent. But I don't know. It's not an actual thing for us to like solve. It was probably just like showing it for fun. Corrupt is doing his own thing there. It's not related to the thing that you put, Bob. I mean, you can look at that too, but it's not like related to what you put. If that's what you were asking. You should focus on your mid semester. Yeah, that's fair enough, Han. So contour integral. So curvy parts of the area they just seem like they'd be harder to work out. Yeah. Think you have a picture of the strip now? Oh, I mean, there's this one that Bob sent me, but yeah. Okay. Glad there's matching. Oh no, I already looked at that one. It's about 2 or 3 minutes too that makes it come out nicely. Yeah, I'm not sure. 35% semester, 30% assignment, 35% final. Wow. Yeah, if you mess up the mid semester, you're like nearly done for. Given a weird ass system with non-commutative addition, what is K plus B? Fitzmac, are you genius? Nice time when people can't solve this. Yeah, it's early on when I started streaming. There's someone who gave me It was like that, but it was like one of those like instead of the variables, they have like pieces of fruit where it's like, you know, grape to the apple plus pear to the apple equals watermelon to the apple, and it's just like Fermat's last theorem or something. 99% of people can't solve this, which I guess is true. Well, more than 99%. Oh my god. So you don't have any assignments, Bob? Or they're at least not graded? Hmm. Do you have to go to uni if you don't want to? Wow. I mean, I think I don't think anime classes graded you on attendance. I think they might threaten to drop you if you don't show up enough times or something, though. I don't remember. Took one class at college was 90% final? The test was fair, though? Okay. You didn't even live in the same city as uni? Oh, so did you, was your uh, move to the same city now? In the meantime, since there's a question from chat, I'll spend a bit more time on math. I think we'll just keep on looking at some multivariable calc stuff. Just to try and refresh myself. Like, directional derivatives, I don't really remember that well, so let's look at those. You moved there now? Oh, okay, nice. Yeah, Han. I do dual stream to YouTube, and YouTube doesn't get the music. But I do realize that music is kind of like, some people seem to really want it and others don't. But yeah, I realize it's not everyone's like first choice of things to like look through, but that first YouTube link there would have it without music. Some death metal set the vibes. Oh, well, I mean, now you're speaking my language. Hey, Anders. Okay. Well, let me get you hyped up. Where is it? What playlist would I have it in? Oh no, it won't be in that playlist. Let me. I'm just gonna look it up. Oh, is it gonna be super loud in a second? Oh no, it's okay. It's pretty loud. I'll turn it down a little bit. Cal Bob from hell, you know him, Bob? I don't look at the county. I have a Gojira picture on the wall. Yeah. Do you like Ghost? Oh, there's one Ghost song. Kiss the Goat. I think that's Ghost. That I know. Kiss the Goat. Yeah, that song's a banger. I don't think I can name any other Ghost songs though. Smash if you have a good day, bad if you have a bad day. I mean, if you want to get in the right mental, just blast some Pantera. How dare you lower the volume of Pantera? I thought I could say level as my voice. I was like, oh, maybe it's a little bit too loud. Serious? Oh, that's maybe the one other song that I know. Wait, so Anders, do you like metal too? I might have that even in the playlist that I normally have. I can't remember. Super paired but paired enough-ish. There you go. That's something. Of course. Okay, I see you. Justice for metal, dude. I feel like there's been a couple people who come in chat and said they like metal. Like I almost want to do like uh, a metal like song share stream or something where people can like request songs and just like jam out. I probably wouldn't want to do it like maybe I would do it during normal match stream too, but turn Dawn down, turn Pantera up. Yeah, some kind of like a music sharing stream might be like fun. Um, song has one more minute on it, and then since Fembox put Ghosts in my head, I do want to listen to Australian metal from the mid 2000s. I can't think. Oh wait, One Hand Killing by I forget what band it is. Carnival. I've heard that name. The band is AC/DC. Yeah, I think metal's easily my favorite genre of music, and then maybe not easily, but it's metal's my favorite genre. Then closely followed by rap, and then I listen to a good amount of other stuff too. But those are my two like favorites. You know, Australia for 2 years and then broke up. The lead singer went on Celebrity Big Brother. Interesting. It's like proggier stuff. I'm really bad with like the subgenres of metal, but I think the people I like are prog. Oh yeah, you just asked Anders. Yeah, I'm not good with the subgenres. Like my favorite band, Ginger. I heard them described as like progressive groove metal or progressive groove funk metal or something. I don't know what it means though. I should probably turn the music down a little bit. Know that it takes two. Luckily, he wants to do you too, Satan. Yeah, I don't tend to play metal stream just because it's kind of like polarizing, but yeah. Made a man from high school's in a pretty big metal band, Make Them Suffer. I don't think I've heard of them. I was a ratty little metal kid running around to all the gigs a long time ago. Oh, nice. Oh, that's right, Bobby said you liked it Disturbed. Ginger is basically death at its core, but mixed with other sometimes unexpected stuff like reggae. Okay, so maybe that's where like, yeah, Ginger with J's. They're my favorite band. Hardcore or metalcore, more specifically metal. Okay. Yeah, like my favorite band is Ginger, and my next favorite like metal band is Gojira. Uh, Reggae like elements, I think, or I don't know, like elements of other genres. I'm really bad at. I don't know anything about music genres. I just like the sound of it, basically. Yeah, Tatiana, I think her name is, or something like that. She's awesome. $900K monthly listeners on Spotify. Wow. Um. All right. Well, as long as we're on metal, I'm just gonna play a Ginger song as well. Turn up just a little bit. I am like half reading this directional derivative stuff, I promise, but I'm kind of like more into the metal now. I always thought math and music go very well together. Yeah, if I'm doing math, I usually want to listen to music of some kind, or just have some kind of background noise. I mean, if I'm watching like a stream or something, it kind of like distracting. So I think music is a lot better for like focused math. Supporting Bring Me the Horizon on their tour of Australia. Wow, that's awesome. Always have music on while I'm studying. Yeah. So we're going to define this. Let's suppose that a particle is sitting at x naught, y naught. The particle will move in the direction given by changing x and y. Yeah, I was super into them, Bring Me the Horizon in high school. I haven't listened to them much since, though. It's kind of weird how, like, for the most part, accents still really come through when people sing. I feel like for most singers, they just sound American to me. Trying to get a degree over there. Too old to be a ratty metal roadie. Yeah, so this is one of the few metal bands I found where there's a female lead singer and she does the screaming herself. There's other ones I found where there's a female lead singer, but then like a guy in the background does the screaming. This is all her though. This is Cloud Factory by Ginger. I think my favorite song of theirs. Like the limit definition of a directional derivative. Do you scream for a chick? Yeah. So you found a very cool math fact? What's that, Bob? Tower got a better beard than you? Dang beer the components. Interesting. Okay. Let PQRS be a quadrangle. What is a quadrangle? Oh. So it's like a quadrilateral, but it can like intersect itself. I should go. I'll go back to playing, I guess, more widely palatable music. Are we on that song? Okay. Coach Auto is probably better. Oh, okay. A, B, C, D be the midpoints of the sides. Then A, B, C D is a parallelogram. Really? Did you count one up with the metal? Oh, really? Maybe that's the key then. Don does metal and math. A lot of people think my name says Don does meth, and I think it'd be pretty funny if people thought my name was Don does metal and meth. Like, wow, guys out to party. I do like this music too. It's just a different vibe. That's crazy. The glass video is just off stream. Oh my god, I read that as meth when you said that too, Fembox. I was like, wow, you run a meth lab? I don't think can you say that on Twitch? You're secretly Walter White. Mathematics or mathematics. Keep saying math is indistinguishable from meth. I mean, also, like Australian, New Zealand, or even English, all those accents just blend in together for me. South African too. Also, South African accents are kind of like all over the place, so you can sometimes like kind of figure them out. Math implies being on meth, but not the other way around. It's a one-directional implication. Oh god. The Aussie accent is the best. It is fun. But yeah, there are some Aussie accents that are really distinct from like English accents. I guess English accents is a pretty huge umbrella. Meth is injective but not surjective. I guess with Aussies, it's kind of like the inflection, I guess, to me that's different rather than like the actual accent itself. Maybe inflection is part of the accent. I don't know. All right, so the directional derivative we can say is the partial with respect to x times the exponent of the direction plus the partial with respect to y times the y component of the direction. And this is how fast the function is changing at a point when you look at a given direction. Depends where you go. In Australia, go out bush or to Puerto, and there'll be a very strong accent cities, not different to English. Okay. Remember when I was taking combinatorics, I posted when I was a kid, I was afraid of injections. Now I'm an adult and I'm afraid of injections. Oh, my non-math friends thought you were an anti-vaxxer. Oh no. I can definitely see that interpretation. Anders, I just generally wanted to brush up on multivariable calculus. And I've kind of been getting the feeling that like studying the abstract algebra on stream, I kind of been feeling like can come off as like I'm trying to steal like Pen Center's thunder, and that's not my intent, and I don't want to come off like that. So it's like I'm kind of debating whether I want to still do it on stream. But I don't know. There's like a few things in general I mentioned in settings, like multivariable calc I want to refresh on, which I think will be like not that bad. Study measure theory. Oh god, I would love to be able to avoid measure theory for my entire life. So like I kind of want to brush my multivariable calc, and I hope that beats something that's pretty like low hanging fruit. And then I generally would want to like do more analysis and do some physics as well. Yeah, so I did message Penn just like being like, you know, I didn't really think about it, but you know, now that I think about it, like this could come off as like trying to take someone else's like thing, and that's definitely not what I want to do. So I don't know. I guess it's like a weird like thing. And I did it first because I figured like, oh, you know, I'm learning this for the first time, so I'm gonna just fall super behind in it, and it definitely wouldn't be like that. But even then, I'm not sure. So I'm still gonna like study it. Just I don't know if I want to do it necessarily on stream. I don't know. I also tend to overthink things too, so I'm not really sure, but it's like math is for everyone, but I don't know. Streaming is like a different thing, I guess. Turning the problems he hadn't assigned. Yeah, or at least like I figure if there's enough of a lag, then like maybe, but I don't know. It's been like an internal like conflict for me since like I kind of realized it like yesterday. So I don't think you'll ever willingly study it after the semester. Oh god, I forgot how you pronounce it. The goddamn Dirichlet and his counterexamples. If I was Raymond, I would hate him too. Sure, more problems he hadn't assigned. Yeah. Yeah, I don't know. Like I said, like maybe there is an answer there. I'm just like, I don't know. I want to think it through more. If I ever do return to it, I want to divide by zero numbers. Just make a wheel algebra. I don't know what wheel algebra is. Feels everyone when we reviewed Zach's problems for the real analysis course. I think so, because those were assigned to us to do. Which I guess you could make the argument that Penn Center is assigning problems to us to do as well, but I guess the idea is the content of his streams are him going through the book and solving problems, and if the content of my stream is the exact same thing, that's where I'm having that conflict. Whereas Zach, you know, his stream was you know, guiding us through these problems, and then if I then on my stream keep on going through those problems, I don't think that conflicts in the same way. So the chat's fault. We're not posting our problems to keep you busy. Yeah, at the end of the day, it really is just a filler thing because my primary thing that I'd like to do is homework problems from people who like need help understanding concepts. And to be honest, like we had a good few from Thunder there, and we had a few others from other people in chat that were super fun. But the stream still isn't a place where I get enough to fill up. Streams like the link I'm doing now, like 3.5 hours. I've had good days where they fill up like 2 hours or so. Yeah, problem develop the field of algebra of wheels. You know, that sounds simple because, you know, if a wheel is just a circle and circles are always symmetric under every transformation, then you only ever have one element. I don't know. That's my algebra. Answered. just playing Scribblia with math terms. I don't remember hearing that suggestion. I've heard of Scribblia. I don't know how it actually works though. A wheel algebra ever a vector space? I don't know. I forget how Scribblia like actually works. I think it's like Gartic Phone where you draw things. I don't remember. Is it just Gartic Phone? I haven't seen this one. Let's find square root of 2 plus root 2 plus. Oh yeah, the nested root. That's one that we did as part of the real analysis class. I forget how you work it out though. Oh, it might be golden ratio, but why? And just be hide for Scribblia with math terms. I mean, that's one where you can like a lot of streamers will like get their chat involved too, right? I wouldn't mind like trying it. I hear this nested root situation again. There's a trick. You say that eventually the terms get close enough together that you say, yeah, what Bladwey says. You can solve that for x. That's right. And then I think that'll give you the quadratic for the golden ratio. Yeah, I guess Scribblia with like regulars who I trust would be a better call than Scribblia with random strangers. Oh wait, no, that root 2 doesn't converge to either of these. You don't remember what it is? Doing on there, I'll draw a wheel algebra. 1.8 cocksucker machine. Oh, it does just go to 2. Really? So getting 2 from that quadratic was the expected answer? Okay. So yeah, I agree with what Bob and Bladwey said then. For after a certain number of terms, the terms become close enough together that you just call them both x. Solve for x. Zach! The Zachinator! Now at Wendy's. How's it going? It's a great joke. Works on so many levels. Was that the best joke I ever made? Oh, did I? Is there more there that I'm not seeing? And if I make a stream, yeah, glad to have you. Especially since you're having that like crazy week, it sounds like. We had some really fun questions earlier, although things have slowed down now, so Finvox was talking about this like whole nested square root of 2 plus square root of 2 situation. I think we just solved and worked it out to be 2. Yeah, that's the golden ratio quadratic there. That's right. Yeah, I remember we had that for the analysis class at some point too, but I think with like 12s or something. But I can remember the actual technique, so. If you wanted to get it to be the golden ratio, what would you change? Would you have it with 1? Oh, square root of 1. This isn't going to be anything, is it? Oh wait, this is the golden ratio. Yeah, if you do it with 1s. Because the golden ratio is like 1.61 something. Oh, that's right, continued fractions also. Specific geometry, the cox. Yeah, Han, there's a whole like at least half-hour segment of one of my streams recently that was dedicated to looking at 30 sounding math names, and that was the one that started it. Equilateral pentagon, the ratio of the diagonal and a side is golden ratio? That's weird. And so for the continued fraction, I assume you do the same technique as with the nested square root or the continued square root. I guess you get another quadratic, don't you? If you have 1 over 1 plus x equals x, you would have 1 equals x squared plus x. So x is equal to plus or minus 1. You just get 1? Like, I guess positive 1? That's weird. Or did I mess it up? Oh, that one becomes the golden ratio? Oh, there's a 1 on the outside. Then it'll make more sense. I messed up my nesting or something. Oh no, I didn't. 1.6. Yeah, okay. You need a bunch of continuations, but I think you'll eventually get to the golden ratio. That stuff up when you took number theory. Oh, okay, nice. Or by Fibonacci numbers. So you turn upon to get x squared equals x plus 1. Oh! What? That's so weird! I didn't even thought about that with a Fibonacci, like the recursive definition. Is that a coincidence? You're reading about this stuff at a math class at your university? Oh, cool. It's not a coincidence? Huh. Ratio Fibonacci numbers tends to golden ratio. I mean, I'm trying to figure out like how that I knew that. I'm trying to figure out how that relates to the recursive definition becoming that same quadratic. Oh yeah, you weren't there for the grand finale, Bob. Actually, there's still time. You don't have to miss the Zach is gonna make some certificates for people who were there for at least half the courses. And that's potentially gonna be on Saturday, I think. But yeah, for the last like 2 classes, we combined both the sections. Thinking in Hilbert's Hotel? Oh yeah. Dude, I still feel kind of proud that I figured out that powers of primes thing. Because I think I've heard of the problem before, but I didn't know the solution at all. And I was like, oh cool, I actually managed to figure out for the n times n thing that you can use the powers of primes. Oh, you know what? That reminds me. I did want to look at. There's apparently a way to do that without gaps. With the Wikipedia page. tell us this? Probably a bit busy studying set theory, so you're kind of doing similar stuff. Oh, nice. Next class in September. Hype. And then Bob, for you or anyone in chat who doesn't know about it, there are complex variables class, a class for complex variables, I should say, and a class for differential equations planned for the summer. Then a potential course from Zach in September. I think it's to be decided. Making a huge mistake. I found it was a mistake after the course. But set theory? Aleph one. What is Aleph? Oh, squiggle N? Oh, it's for like the relatively like different types or different levels of infinity. Well, wait. If the natural numbers are 0, shouldn't the real numbers be 1? Or at least more than 0? Natural numbers, integers, rational, constructible, algebraic, computable. Are computable numbers real numbers? No. Didn't we read the left by Borges? I sure didn't. How the continuum hypothesis may still be unproven. Your numbers are bigger, but you can't say it's the first one that's bigger. It's proven that it's unprovable? Oh no. Well, oh, okay, oh, a left null. That's, okay. That's the distinction. Okay, so it's definitely not a left 0. It's not necessarily a left, we just don't know what the a left is. That's my interpretation of what's happening in chat. Oh, wait, you're saying overly about the improvable part. Okay. It's a short story about 15 pages. Oh, really? A story? Like, is it about like the math Aleph, or is it about like something else? I did watch that. It was really interesting. Prompt 5 from this problem set for more about the Pentagon and globe. Ooh, okay. Girdle rears his ugly head again. Mate in Omega. I want to read about the continuum hypothesis, and I'll look at this. Carnot set of real numbers is 2 to the Aleph not cannot be determined from ZFC, where this number fits exactly in the Aleph number hierarchy, but it follows from ZFC that the continuum hypothesis is equivalent to the identity. Okay, so if the continuum hypothesis is true, then it would be Aleph 1. Otherwise, it's just 2 to the Aleph not, whatever the heck that means. Can either be proven or disproven within the context of the axiom system. Okay. Day 5. Platypi ease my dreadful aching stomach? P-E-M... Oh, PEMDAS! What a weird way to remember PEMDAS. Anyway, you're talking about prompt 5. Can explain it well enough in English, so just like a P. Oh, okay, fair enough, Anders. This is a point in space that contains all other points. Obi, hey! Hope the move is going well. 11? Okay. The Pentagon Chris? Hi, Chris. This is Chris, guys. In Borges' story, the 11 is a point in space that contains all other points. Anyone who gets into it can see everything in the universe from every angle simultaneously without distortion, overlapping, or confusion. The story traces the theme of infinity found in several of Borges' other works, such as the Book of Sand. Oh! So it's like a way of explaining different levels of infinity? Huh. I prefer Triangle Dawn. Hail, Chris. Did our walk through the new place today, moving from 10 housing next week? Oh, awesome. Well, best wishes for it to go smoothly. For now, I have to mark my triangles Dawn. It's perfect. We should have to mark your triangles. Oh, you can't do Bob. Okay, never mind. I mean, you could do Bob. You could do uppercase B and lowercase b. I live in Greater Yorkshire, getting documents in order. Awesome. Triangle nod. Zach for quadrilateral. Yeah, I don't even know what polygon is going to go with Penn Center. I guess there's a lot of E's and N's in Penn Center, though. Penn Center will do Penn? Okay. I guess, yeah, I mean, Dan could be a triangle, too. Or, yeah, D-A-N-Y. Obi-Wan? Oh, that works out well. You can even... In simplex pachinko, there's an N that's repeated and a P that's repeated. And an I. Okay, never mind. I thought there's only one letter that repeated. I should start using this. Probably got to figure to keep in mind when trying to find cosine 72. Oh my god, yeah, we had that problem before, Fembox. Yeah, from bio. Oh god, the talking in that song, like, tripped me up. Hexagon Obi-Wan? Yeah. So if IR is 1, what is the length of CI? So this is the day where we expect to get 1.61 something. How would you go about? Octagon works for N simplex. See, oh yeah. Why is Chris going clockwise? I thought that's how you normally name the vertices of polygons. You go clockwise. For similar triangles, instead of using trig, you may want to label some more points too. Oh no, similar triangles. Yeah, how you... Oh, excuse me. What similar triangles? Oh, we have a similar triangle. Like, this is parallel to this little one in here. Those are similar triangles. Doesn't help us immediately, though. Here we always do the counterclockwise. I mean, I'd rather just everything be clockwise, everything be counterclockwise, to be fair, so I kind of like that system more. There's other places where CI over IR appears in the figure? They say to avoid using trig. It's similar to RIH too. RI8? Really? What? RIH is congruent to HS some other point. Oh god. This is one of those geometry problems that requires creativity. Which is my worst nightmare. Well, at least this type of geometry problem. The more proof-based geometry class I had was actually kind of fun. So you mentioned the midpoints of the sides of the quadrilateral form a parallelogram. Yeah, I think that was Bob. Angle IRH is 120. RH is congruent to HS some other point. RIH is congruent to HS some other unlabeled point. That intersection seems reasonable. Okay. So that means that these two are both length 1. Those parts of the diagonals. Probably ones I should do on the whiteboard so I can actually label things, but I'm being lazy and just trying to do it mentally. So I think that would imply that all these other like diagonals are similarly length 1. Lazy. Yeah. Um, Curve the sides are parallel. Make a quadrangle crossing two sides. Oh, I think Bob later said it's supposed to be quadrilateral, not necessarily quadrangle. Like it might have been a translation issue. What else can we do here? True mathematician, I ignore all the edge cases. Bust out law of cosines to figure out like HS or HI. I guess we could. We're saying the angle is 108. I'll believe that without even checking it. So what would law of cosines be? It'd be c squared equals, or c equals square root 1 squared plus 1 squared plus 2 or minus 2 cosine 108. You get law of cosines. Ends it at no trig. Oh yeah, Wolfram just uses that cosine of 36 or cosine of 72 thing. But if you local author books and intend to blow through them in the next couple of weeks, like math books are just books in general. I guess that's a good like pastime either way though when you don't have all your stuff. Ptolemy theorem. Ptolemy? I guess it makes sense. Ptolemy made a theorem. I just know Ptolemy is like an astronomer. Actually, we talked about Ptolemy's theorem before, I feel like. Ptolemy's sum and difference formulas? Really? But I don't think that's what we want. I think we want those. For a cyclic quadrilateral inscribed in a circle, the product of the diagonals equal the sum. Oh God, we have to make a circle. Oh God, it's gonna be hard for me to apply. Sci-fi panel at the library this Thursday, so I'm trying to get through Alien Clay by Adrian Tchaikovsky before then. Ooh, nice. Isn't Tchaikovsky a director or something? Or like I thought Tchaikovsky. I associate that name with like not books. Maybe I am just wrong though. Maybe it's a different Tchaikovsky. Oh, this is the Tchaikovsky composer. That's the one I was thinking of. Okay, and that's a different Tchaikovsky. Okay. Fair enough. Isn't there also a direct? Okay, no. Let me. What other Tchaikovskys are there? Maybe it's only the one. Okay, fine. I was thinking because I recently read a book called Roadside Picnic. I forget who the authors were, but there's apparently a movie about it. And I thought the director of that movie, for some reason I was thinking Tchaikovsky, but it must have been someone else with a similar sounding name. A friend did a book club by him, invited him out for beer and discussing his book. He's not able to actually come, but zoomed in. Ooh, that's awesome. Yeah. BD and AC diagonals in pentagon. BD and AC. Woohoo, hey! How's it going? It's going good for me too. How are your classes going? Woohoo. Hi Don, is math important? It's not. Depends how you define important. Warm hearted American girl, I guess. You can live your life knowing basic arithmetic and get by and live a full and happy life. Or you could learn a bit more math and like make better financial decisions. and learn even more math and either get a job using that math or just treat it like a puzzle, like people solve a Sudoku or a crossword or something. At the same time, most important, least important thing in the world. Yeah. So if you're not interested in learning math, I'm not going to tell you that you need it to live your life, because you don't. Excuse you, car. I don't know if that came up on mic. I would say if you should realize that your life, that maybe you have a goal in life that might require you to do some math, like if you want to go into like any kind of STEM field, you usually have to pass a calculus class, which is a pretty big obstacle if you've been skating by in your previous math classes. It's certainly not impossible. But outside of stuff like that, yeah, I mean, you don't need math to live a full and happy life, I guess. It can make certain parts of it easier, or it can present fun problems to work on that you just enjoy doing. But doing math question right now, I'm not sure I did it right. Yeah, sure. Once you're ready, just type it out there in chat, or you can put it in Discord. There. Oh god, that sub badge looks kind of terrible with the gold ring. No worries. In the same time, oh yeah, I already read that from Bob. Many people may struggle through life with very little math understanding. I often wonder what that must be like. I mean, I don't think they're necessarily even struggling. I think it's people who, I mean, like the type of person where like they're really like good at working with their hands, and you know, you give them a machine, they can break it down and understand it, but they also like, you know, dropped out of school or something and know barely any kind of academic knowledge. That's a terrible way of phrasing it. I think you'd be successful in life without math. This might not have as good of a time. Look at the IRHG quad thing and use Ptolemy. Yeah, let me look at what the Emperor is saying. I have a question. Can you explain Q minus 12 equals 1 with one-step equations and integers with 6th grade math? Oh, sure. So yeah, if you just want to solve that for Q, we can certainly do that. I'll come back to Chris later. So yeah, welcome in Z Ember. Sorry, it took me a second to get to you. Trying to catch up on chat. So yeah, it's just learning to isolate variables here. I can definitely help you out. I mean, you don't say they're struggling and not realize it too. I guess $10. Is it getting dark? I think it's still bright enough. So my interpretation of your question here, and please tell me if I'm wrong, is that you have Q minus 12 equals 1, and you want to solve it for just Q? So I'll show you the way that I was taught to do these when I was first learning. You may have been taught to, you know, draw it in a slightly different way, but the thing that's stopping Q from being isolated here is the minus 12. So we want to undo that minus 12. And we undo a minus 12 by doing the opposite operation, which is plus. So since there's a minus 12, let's do a plus 12 to each side. And so, you know, because we set it up in a smart way, 12 minus 12 is 0. So we get just Q. You know, you could say it's Q plus 0, but Q plus 0 is just Q. Is equal to 1 plus 12, which I'll do in 2 steps here. And 1 plus 12 is just 13. Thanks for the follow. Oh, and you're my 650th follower. Thank you. Even more. Equations like a balance. Yeah, exactly what Fembox is saying. So you're allowed to do a lot of things with equations, just you have to make sure you do it to both sides at once. So I undid that minus 12 by adding 12 over here, but you can't just do it for free. You have to add 12 to the other side at the same time. So If you have more, please feel free to keep them coming, or if you have a question on anything I said, please let me know. No worries at all, Zamber. And if you find yourself in need of math help, and I'm not online, let me call out other math streamers who are also great. There's that entire list of people there, and every single one of them can do a very good job of explaining the type of math that you're working on. So I mean, you don't have to do anything, but if you're ever in need of more, if you think you might be in need of more math help in the future, I'd recommend you follow them all, to be honest. Yeah, welcome in, and thank you for the question. Go to math streamers, yeah. So you have more, keep them coming. If that's it for now, then great. And so Bob was saying something about good old friend Chris here. IRHC quad thingy and use Ptolemy. Okay. This is getting to the limits of my mental math. This is a world of pure imagination? It is. It's a remix. Okay. Sorry. So what is this thing? So are we going to draw the diagonals? Oh no, the diagonals are already drawn. That's why you use it. Okay. So AC and BD are the diagonals here. So, okay, maybe I can still get away with doing this mentally. CR and IH are our diagonals. So CH times IR. And they're equal. So we can even say like CH squared. A, B, C, D, A, D, B, C. So opposite sides multiplied and added. Okay, so CR times IH is equal to IR plus CH, or IR times CH plus CI times HR. Mental math, don't fail me. No, I can't. This is too hard for me to do mentally. All right, Chris, you win. Dude, I wish more geometry problems would name their shapes like this. It's kind of fun. Could you use your whiteboard? I just don't want to. I don't know why. Requires standing up, I guess. God, I really need lighting. Okay. Green. Actually, how's the black marker doing? It was kind of drying out, so I stopped using it, but let's just see. How do you draw a pentagon? Let's draw it really tiny. I have this giant whiteboard, but I'd rather just draw it really tiny. Because that's the intelligent thing to do. I'm not drawing this right. Okay, you have to angle. These in a little bit. There we go. Chris. Then we draw the pentagram. Name that. Oh, wait, dude, check this out. Check this out. Okay, okay. P R A. Oh no. T1 and T2. Oh, blue marker? Okay. Christ, get ready to meet the quad thing. Chris. Change the chalk, replace the whiteboard with chalkboard. Oh god. Bob, I didn't know you were on team chalkboard. All right, blue. Okay, so we take crit. That's not R, that's C. Okay, so we would say 1 and 1 and 1. I just didn't draw it very well, did I? Okay. We would say that CR times IH is equal to IR times CH plus CI times HR. That's just on Team Chalkboard. Chalkboard all day. Oh my god. I just hate the feeling of chalk. Okay, so we can make the realization that CR equals IH. So just say CR squared. IR is 1. CH is 1. CI is unknown. HR is 1. One plus CI? So where does this get us? CI equals CR. What? Oh, are these similar? You get the polynomial we talked about? Really? Wait, CI equals CR. CI equals CR? Oh, are we looking at like a different part of the... CI equals... Oh! Okay. It's easier when I look at the entire thing. CI does equal CR. And then we get our good old... Wait, what was the goal again? To get CR? CI. So it says CI squared is 1 plus CI, and that's our... Okay. That's the golden ratio. That's crazy. Yes, look at the pentagon. Yeah, I got there eventually. What is this, like, sheet, by the way? Don't try this at home. All right, you're not at home, so it's okay. It's you're in a classroom. Yeah, I remember seeing Ptolemy's theorem somewhere before. It never comes to mind as me. Never comes to mind for me. That was neat. I kind of wondered what's on the tough stuff part of this. 43 by 30 rectangle with as few squares as possible? Ooh. I would assume you have a 30 by 30 square. Like, you always make a square of the shorter side length. And then you're left with a smaller problem that's the same, like another rectangle. My professor telling me this is a theorem you will see the proof once and will never remember it, but it's useful. uh. Consider an infinite set of squares where square n has side length 1 over n. Turns out these squares have a finite total area. Infinite set of squares where square n has side length 1 over n. Okay. Turns out these squares have a finite total area. 1 over n squared. That's just the power series. And then p is greater than 1. All fit in a 1 by x rectangle. Find the smallest possible value of x. Really? You can find the sum of 1 over n squared? It'll be 1 squared plus a half squared plus a third squared plus a fourth squared plus a fifth squared. It's pi squared over 6. I believe it. When your AP calculus reading, I saw someone with that tattooed on his calf. I don't know. I'm another person who wants any type of tattoo. I definitely, I don't know, man. Basil problem? Basil's pretty delicious. Challenge for a mathematician, or there being an absolute Chad proved in like 6 ways? Wow. It is pi squared over 6. So he uses the Taylor series expansion of sine. Oh, Phobos, hey, ultimate cheat sheet. If you touch all infinitely many squares, what's the perimeter? Yeah, I was thinking about that too, because that's 4 over n, right? And that's the harmonic series. If you touch them all together, oh, I guess that's different. Your stories about Euler, just like you don't even believe them, is like a legend. Really? I know almost nothing about Euler's life. You have a poster of him on the wall of your office? Wow. Yeah, the history math class that I took skipped right over Euler. The Weierstrass factorization theorem shows the left-hand side is a product of linear factors given by its root? Really? What? You could write sine of x as a product of its roots? I guess if you could write sine as a power series, then that's a polynomial. And that can be written as this product of its roots. Okay. That's kind of crazy. Yeah, I forget who we did. Who did we talk about? I feel like I was more focused on like the ancient math, I guess, like Egyptians, Babylonians, a little bit of China and in India, and the Greeks. Actually, I think no. It also went into more modern stuff. We talked about Gauss. We talked about Gödel, Newton. Yeah, my professor claimed that the greatest mathematician of all time, you could debate between Gauss and Archimedes, which I don't know enough to disagree with. Archimedes always seems like one of the dudes who was really like ahead of his time and probably would have done more if he was born later. Gauss, Newton, Archimedes. Oh, is that your list from blocks of the greatest mathematician? So Gauss is number one, Newton number two, Archimedes three. Are you saying that Newton, maybe I don't know, like first or not, but Newton better than Leibniz? Leibniz, how do you pronounce it? You'd say Euler number one. Ooh, interesting. Okay, well, I'm starting to lose the thread of this little like proof thing here now, but three blue, one brown is a video about this proof. Okay, yeah, I'll probably explain it in a way that I understand more because I'm getting a little lost in Wikipedia's explanation. You see some of the big names? Oh, okay, never mind. You're definitely partial to Euler? Okay. Um, that is fair. If you compute the total perimeters of these squares, I was kind of one thing about these questions. I was kind of curious. If you really want to feel weird, compute the total perimeter of these squares. Because that would be the sum of 4 over n. Oh, it is the point that it's going to diverge? So it has infinite perimeter and finite area? I assume that's the point of the question. You agree, Phyllis? Okay. Oh, Gabriel's horn. That's one that I learned about. That's it's like finite volume and infinite surface area or something like that. But infinite surface area but finite volume. Okay. Yeah, it's kind of a crazy one. You could fill it with water, but you couldn't paint it. Well, you could paint it. You just need infinite time, I guess. And it's really just 1 over x, which is kind of like crazy. It's not any like super exotic function. Fun question. 1908, people started releasing books with Euler's works. First edition had 748 pages. In what year did they stop releasing books? And all his work covered. Really? Well, I mean, I guess Fenbox may have just spoiled it. They are? Really? So they're still going. They haven't published all his works? That's kind of crazy. It's the 4D shape with finite 4D volume but infinite 3D surface area. Oh god. The 4D shape with finite 4D volume. Infinite 3D surface area? Oh no, I don't care at all, Fembox. I was just like for fun, like guessing. Dude did most of his work while blind? I didn't know he was blind. Okay, we're looking at Euler's Wikipedia page. Okay. Already the dude has terrible taste in hats, but I can look past that. It's not even a hat, it's like an old shirt or something. But Swiss, okay. Yeah, I remember there were some French people who were asking for help, or they asked like what E is as a number. I was like, oh yeah, Euler is spelled like this, but it's pronounced like Euler. Might be weird. And they're like, oh, we're French, so it's cool. But Euler was Swiss. Maybe it's in the French speaking part. I don't know. Ooh, Gauss like Euler's works. All right. Oh, I guess this is the stuff that's still being published. It will consist of 81 quarto volumes. Wow. He created a lot of the notation that we use a lot. I always thought it was Descartes who did a lot of it. Which I know Descartes also did a lot of it, but that's a lot of notation that he contributed that we still use. Oh yeah, I love Wikipedia has the signatures. I know that Gauss has a pretty crazy one. Do you know who's the first to use Venn diagrams? They call them Euler diagrams. No one would know who Venn was. Like, look at Gauss's signature. Obviously, they didn't have to do it this time. Just imagining trying to do that entire signature when you're signing the receipt at the grocery store or something. It's got to be a stamp. Okay, that's the more practical thing, yeah. I'm worried about his actual like life though, because usually mathematicians are kind of crazy. The cool mathematician types out their names in LaTeX and make a stamp. That does seem pretty hardcore. Hell, you learned from Bernoulli. Oh, there were a few Bernoullis, weren't there? I assume it's the Bernoulli. Or there was something where, like, there were two brother mathematicians, the same last name. But was it Bernoulli? That's right. Okay, it is Bernoulli, yeah. And yeah, there's a third one, not a brother, but same last name and like an uncle or something. A lot of really good mathematicians. If you hear just Bernoulli, it could be any of them in theory. Daniel was the son of? Okay. Of Johann? Does Wikipedia tell us? Wait. His brother was an academic advisor? And his child or nephew was his student? I guess that makes sense. Mathematician to a pastor? Oh, for Euler? Those who were super jackasses? Oh, really? They're like 30 Bernoullis? Yeah, I mean, I think it was those three like were like the major ones, but yeah, a bunch of them have made contributions. Hmm. And so under consent became a mathematician instead of a pastor. Huh. Yeah, I mean, glad his father was cool with it, I guess. So another Daniel Bernoulli is an economist at Basel about 20 years ago. Ooh, that's super cool. I assume there's a relation there. And someone smart is in their genes, it must be. You know, I'm not seeing anything that, like, crazy. Direct descendant? Wow. Oh, this playlist just looped around. Oh god, okay, this Wikipedia page is a little longer than I thought. Oh, let's look at the career part. That's probably why I wasn't getting crazy. Okay, well, let's read this little part and then I'll look at something else. Almost blind in his right eye. Now, fewer distractions. All right, that's the bright side. Oh, he was nearly totally blind in both eyes after a while. Jeez. And he still was doing math. One math paper every week. Oh my god. He died from a brain hemorrhage? Oh my god. Jeez. Okay. What was I doing? Oh, dude, this is a tangent. Yeah, I think his years, that was about 70 years. Like, I didn't quite do the math, but he definitely lived a long time. Um, yeah, I started by looking at Hilbert's Hotel. I can still see like the other so with this thing, I was able to come up with a prime powers method on my own. What else is possible? Oh. Should we have certain room empty? Compare the lengths of N and C. What the hell? I'm already lost in what this is doing. Just use triangular numbers? Okay, I don't know. I'm pretty lost in all those alternatives. I don't feel like digging into them. No new DMs on Reddit. I'm kind of like I should wrap things up. Is there anyone who's online though? I see Gold is on. Ooh, I do see someone who I haven't raided before, who I would love to raid. I'm going to check on his stream quick though. Okay. I see the tutor wizard is streaming, and the few times I have watched his stream, I love his enthusiasm about math. I'd love to go send him a raid. He just seems like super psyched to do math, and it's infectious. So, / raid the tutor wizard. Okay. So yeah, thanks for everyone who's been hanging out with me. I really appreciate y'all. It's been a fun day. We're doing video games tomorrow. I don't know what, probably Daisy. I'll find out. And then my next math day